All right. Well, why don't we get started? It looks like the attendance is semi-stabilized and more people can join during during the day. So, good morning and thank you for attending today. I'm Jenna Latt and I'm the manager of the off-road control section here at CARB, and we're responsible for the Tier 5 rulemaking. Thanks for joining us at our ninth Tier 5 public meeting. And so today, the focus is on changes since our October 2024 workshop to discuss the Tier 5 standards, the off-road in-use programs, and onboard diagnostics, or OBD. We appreciate all your feedback through the years. We've definitely been considering it and looking at it very carefully, especially all the comment letters and meetings. Um, Staff spent 2025 listening to stakeholder concerns and have made significant changes to the potential Tier 5 requirements. Some highlights include that we pushed Tier 5 final to model year 2036 to give manufacturers more time for implementation. We removed the greenhouse gas standards for CO2, methane, and N2O. And we added an optional Tier 5 interim standard that's EU Stage 5 like to encourage the use of diesel particulate filters to provide for early PM benefits. Since we began the rulemaking process nearly 5 years ago, we've held over 150 meetings with stakeholders and met and toured 5 manufacturing facilities with US EPA and have listened to stakeholder feedback. On February 5th, we posted the potential draft regulation order, or the reg language, as well as test procedures on the Tier 5 website. In today's workshop, we'll be discussing changes as well as the reorganized reg language structure to a standalone Tier 5 document. We'll also discuss the test procedures for Tier 5 and the separate document, the supplement to the Tier 4 in-use test procedures for model year 31 and subsequent years. My staff, Dr. Shun Nakao, will be presenting first today and will review today's agenda at the start of this presentation, and then followed by Dr. Hanwei Zhu on off-road in-use testing. A Q&A will follow each presentation, and you may type in your questions as we go along, and we will answer them orally. This presentation will be recorded as usual and will be posted after the workshop. That's one of the questions we get. So if you didn't hear it, you can ask it again, or folks who tune in late. And then OBD will be presenting their presentation in the afternoon, followed by Q&A. So your participation continues to make a difference, and we really appreciate your collaboration and all the productive discussions we've had. And with that, I'm going to turn the workshop over to our branch chief, Kim Hebroy-Rogalski.
Thank you, Jenna. No, I just wanted to say welcome, everybody. We're so excited to be able to be here and have this event, and super excited that over 340 people are currently logged in participating. As Jenna mentioned, we released the draft regulatory language and draft test procedures, and we're very eager to hear folks' questions, ideas, comments on those. We welcome you to provide those here or provide them personally to us afterwards, whatever format's most comfortable to you. So yeah, let's kick this off. It's going to be great.
All right. And already we did get a question where people are asking for, will participants receive copies of the slide decks? And the answer is yes, we posted them a week ago. So if you Google CARB Tier 5 and you go to the meetings portion, then you can see all the documents that we've released prior to this workshop. So yes, they're already out, so you can follow along. All right. With that, Shun can get started.
All right. I hope you can see the
Yes.
slide, and so let me move on. So this is today's agenda. As Jenna mentioned, there are three presentations. First one is potential Tier 5 rulemaking, major elements and changes, which is what I'm going to talk about now. And then the second presentation is off-roading use testing elements and changes. And then the last one in the afternoon is off-road on-board diagnostics updates. And each presentation is followed by about an hour of questions and discussion session. And today's workshop is scheduled to end at 3:30 p.m. Pacific time. So if you'd like to call in addition to this Zoom, you can dial the number in your Zoom registration email. And then if you'd like to ask questions in Zoom, please use the raise hand feature or type in Q&A box. And if you'd like to ask questions on phone, please dial *9 to raise hand and *6 to unmute or mute yourself. So here's today's outline. I'll start with background and objectives, and then as we mentioned, prior to this workshop, we released the draft potential regulation order and draft potential Tier 5 procedures for test procedures for Tier 4 and Tier 5. And then today we will explain how they are organized. And then I will discuss changes in various elements, and then we request feedback, and then end with the potential next steps. So as we all know, off-road NOx emissions are significant, and Tier 5 is one of the 2022 state implementation measures to control off-road emissions. And staff committed to investigating a rule designed to reduce NOx, particulate matter, and carbon dioxide emissions from new off-road compression ignition engines. And then the targeted statewide NOx emission reduction from this measure is 10.4 tons per day. This is the Tier 5 public process to date. So this is 10th public event, so including 3 previous workshops and 4 work group meetings. And all of these materials are available in the Tier 5 website. So in this 4th workshop today, we will discuss the changes in the potential Tier 5 elements. So in the previous workshop, we discussed these major elements of Tier 5, which include up to 90% cleaner NOx standard and Tier 4 final, up to 75% cleaner PM standard and Tier 4 final, and greenhouse gas standards, low load cycle, off-road use testing program, and off-road OBD program. And these elements are considered to bring off-road engines to a similar stringency as heavy-duty on-road standards and provide health benefits, despite additional challenges due to greater diversity in off-road applications. And as part of Tier 5 development, we contracted the Southwest Research Institute to conduct more than 5 years of demonstration projects to support the technical feasibility of the potential Tier 5 final standards. Okay, so this slide summarizes the documents released on February 5th. So we released the draft potential regulation order, draft potential California Tier 4 in-use compliance test procedures, draft potential Tier 5 and marine compression ignition engine less than 37 kilowatt test procedures. And then in the draft potential California Code of Regulations or CCR sections, you may notice that there are many sections with sub-numbering or like 0.1, while remaining the current Tier 4 sections unchanged. And so, for example, 2423 is Tier 4 final standards and test procedures, and then there's no change. And then 2423.5 is a new section, and then it's a draft potential supplemental Tier 4 final standards and test procedures. 2423.1 is draft potential Tier 5 standards and test procedures, and 2423.2 is draft potential standards and test procedures for marine CI engine less than 37 kilowatt, which we drafted to harmonize with US EPA. So the approach of adding subsection, subnumbering like 0.1 was used for many of the existing sections related to Tier 4 or used in Tier 4 regulation. Okay, so let's move on to major changes in the potential Tier 5 since the previous workshop. So first of all, we are considering optional Tier 5 interim standards for model year 2031 through 2035. And Tier 4 final will continue to be the standard through model year 2035 for all power categories for all engine families not choosing the optional Tier 5 interim. And then Tier 5 interim optional standard would be comparable to the European standard or EU stage 5, although it's not exactly the same. And Tier 5 interim optional would not include Tier 5 final elements, such as the idle reduction, low load cycle, off-road OBD, off-roading use testing, extended warranty, or extended useful life. And then we are considering pushing out the implementation date of Tier 5 final from model year 2031 to 2034 to 2036 for all power categories, and then removed former options 1 to 4. And then we are considering removing GHG standards for potential Tier 5 interim and Tier 5 final. And then we are also considering removing zero emission credits and zero emission certification requirements. And then we are considering introducing the 2 beam moving average window instead of 3 for off-roading use testing. And more details on this will be presented in the next presentation. SCR inducement requirements are to be determined at this point and will be revised later. And then we are considering maintaining the current minimum engine dynamometer aging hours in California, which is typically 35% of useful life as opposed to 1,500 hours requirement, 1,500 hours in the federal requirements. And as we mentioned, we restructured the draft potential Tier 5 regulation order and then released the draft potential the potential test procedure for Tier 5 and then Tier 4 in use. Okay, so this slide shows Tier 5 elements with minor or no substantial changes from the previous workshops. Off-road OBD will be discussed in the last presentation in the afternoon. Okay. So this slide shows Tier 5 implementation schedule. Tier 5 final implementation would again shift from model year 2031 through 2034 to 2036. And for model year 2031 through 2035, optional Tier 5 interim standards are being considered for 19 to 560 kilowatt power categories, as shown in yellow here. And since it is optional, we are considering ways to encourage compliance with Tier 5 interim. And one possible approach is to tie incentive funding and then California Clean Construction Program to Tier 5 interim optional standard. And we're also considering using the same approach to Tier 4 final plus DPF to gain short-term PM benefit. We are requesting feedback on this. Is there any alternative approach for incentivizing optional Tier 5 interim? So this slide shows the results of our analysis of Tier 4 final certification data, which we use to come up with the potential Tier 5 interim standards. So we analyzed the Tier 4 final executive orders certification data in the corresponding power categories. And then we found that engine families with DPFs had lower average NOx and PM emissions as shown in this chart here. So this chart shows NOx plus NMHC and then PM emission data in the executive order for engine families without DPF and with DPF. And as you can see, engine families with DPF have slightly lower NOx plus NMHC emission, and then engine families with DPF have significantly lower PM emissions. And based on this analysis, we are considering the potential Tier 5 interim standards shown in these dashed lines. This is a similar slide as the previous one, but for 56 to 560 kilowatt power category. And similarly, engine families with DPF had slightly lower NOx emissions, and then engine families with DPF had significantly lower PM emissions. And based on this data, we are considering potential Tier 5I standards shown in the dashed lines. We are requesting feedback. Is there any concern about the stringency of Tier 5 interim, considering that it is optional? Okay, so the previous slide shows the Tier 5 interim standard, and then this chart compares the Tier 4 final standards and then potential Tier 5 interim standards and Tier 5 final standards for NOx or NOx plus NMHC for your reference. This is a similar slide for PM standards. Again, that compares these three potential standards. Okay, so this is the same idea, but in a table. So this compares the potential Tier 5 interim PM standards for your record and then for your reference. And then this is the potential Tier 5 final standards for your reference. These potential standard numbers have not changed since the previous workshop. So the only change for Tier 5 final standard is the implementation timing. Okay, so these are other potential requirements for optional Tier 5 interim. But first of all, Tier 5 interim would not include the new elements in Tier 5 final, such as low load cycle, idle reduction, off-road OBD, off-road use testing, and so on. And Tier 5 interim engines would not generate California averaging banking and trading credits to avoid earning both federal and California ABT credits. So there will be an opportunity to transfer federal ABT credits to California ABT credit banks. So we don't want those credits to be double counted during this interim period. The use of federal ABT credits would not be allowed for certifying Tier 5 interim engines during the interim period because Tier 5 interim is optional. And manufacturers certifying Tier 4 final, Tier 5 interim after Model Year 2036 using the 5% limited production allowance must offset the difference between those standards using ABT credits. And then Tier 5 interim engines would need to comply with the in-use not to exceed NTE emission limits and test procedures for the CARB run off-road in-use compliance program. The lower thresholds for defect reporting and corrective action apply due to smaller sales volume in California. And again, we are requesting feedback. How can we better incentivize optional Tier 5 interim? Okay, so from here, I will discuss changes in various major elements. Regarding zero emission credits, we are considering removing zero emission credits. A potential PACE regulation or phased advanced clean equipment regulation may pursue zero emission credits with the development of hybrid electric and zero emission technology strategies for manufacturers and/or fleets. Regarding minimum engine dynamometer aging hours, this is a summary of the current requirements in California on the left and federal requirements on the right. The manufacturers may choose to ask CARB to approve deterioration factors or DF for established technologies based on engineering analysis, or ask CARB to approve DF based on emission measurements from similar highway or off-road engines, or establish DF based on engine aging and extrapolate the trend to full useful life. So for example, for 8,000 hour useful life engine, the engine aging is 2,800 hours of engine dynamometer aging, and then extrapolation to full useful life, so which is 35% useful life. The federal requirements are essentially the same as California for the first three options, and then there is an additional option of bench aging, the after treatment to full useful life with a minimum of 1,500 hours of engine aging. Okay, so in the draft potential Tier 5 final, manufacturers may choose one of the two options. First one is the same as the current requirement in California, which is typically 35% of engine aging. Or the second option is similar to the federal requirement, except that the minimum hours of engine dynamometer aging are longer, specifically 2,800 hours for 8,000 hour useful life engine, or 1,750 hours for 5,000 hour useful life engine, and then 1,500 hours for 3,000 hour useful life engine. So the rationale for maintaining the currently employed 35% engine aging is that the potential Tier 5 would not lengthen the useful life hours. We are considering longer useful life year limits, but we are not considering changing the useful life hours. Since we are maintaining the useful life hours, we think engine aging hours can be maintained too. We are requesting feedback if alignment with the current federal minimum requirement of 1,500 hours is desired. Please share feedback on why shorter engine dynamometer aging might be considered beneficial. Okay, so regarding California average in banking and trading, as I mentioned earlier, California ABT credit use or generation would not be allowed for Tier 5 interim engines. And engine families are meeting Tier 5 final early in the model year 2033 through 2035 may generate California ABT credits with early introduction NOx multipliers. And then California ABT program would begin with the model year 2036. And there is one-time transfer of manufacturer's California portion of existing federal ABT Tier 4 ABT credits through 2035. The transferred federal Tier 4 ABT credits must be discounted by 70% to compensate for the difference between Tier 4 and Tier 5 final requirements, or Tier 5 final elements that are not in Tier 4, such as low load cycle or off-road OBD. So regarding California Transition Program for Equipment Manufacturers, or TPEM, the start of California TPEM would be shifted to the 2036 calendar year, and then no California TPEM for Tier 5 interim because Tier 5 interim is optional. The total available California TPM allowances would be based on manufacturer's historical 3-year average of California equipment sales for calendar year 2032 through 2034. I apologize, there's an error in the posted slide, so I made correction here for each power category. And then we kept the same California TPM allowances and duration, which is up to 4 years and 80% for each power category, less than 56 kilowatt and up to 3 years and 50% for each power category greater than 56 kilowatt. Okay, so regarding hydrogen-fueled internal combustion engines or hydrogen ICE, hydrogen ICE can be certified as compression ignition engine already under the current regulation. So currently, for certification purposes, for any engines that is not distinctly a CI engine, nor derived from such, the executive officer determines whether engines are subject to off-road CI engine regulation. And when making this determination, the executive officer considers the torque speed characteristics of the engine. And we are considering clarifying the applicability of hydrogen-fueled ICE to the CI engine regulation. And then we already discussed our potential concept for hydrogen ICE in the previous workshop. And then today we are considering adding the following clarifications. First, prior to Tier 5 final implementation in 2036, hydrogen ICE is designed to operate like diesel engines would meet Tier 4 final or Tier 5 interim standards, and then we discuss criteria in the next slide. And accordingly, we would amend the off-road large spark ignition or LSI engine regulation to provide consistency and exclude hydrogen ICE from its applicability. Okay, so this slide is the, I'm sorry, right. This slide is the flowchart for applicable regulation for off-road hydrogen ICE. So the first question is, does the engine meet any of the hydrogen ICE criteria shown here? So if the engine employs boosted air induction, such as turbocharger, or if it's designed to operate an equipment previously powered with CI engines, or derived from CI engines. So if it meets any of these criteria, and then it would certify to Tier 4 final, Tier 5 interim, or Tier 5 final, depending on the model year. If none of the criteria applies, and then it would meet off-road LSI engine regulation. This slide is the same idea. So as I mentioned earlier, we are considering amending the applicability of off-road LSI engine regulation to exclude hydrogen ICE. Off-road hydrogen ICE meeting any one of the criteria shown in the previous slide would certify to CI engine standard as applicable depending on the model year. So here are potential requirements for hydrogen ICE certifying to Tier 4 final, Tier 5 interim, or Tier 5 final. So hydrogen ICE certifying to Tier 4 final or Tier 5 would meet all the requirements of Tier 4 final or Tier 5 with these following modifications. The first one is fuel-related sulfur exposure is not required in durability demonstration for hydrogen ICE because hydrogen fuel has extremely low sulfur level. The second is that we are considering standardizing hydrogen fuel specification for emission testing and service accumulation, aligning with the existing Title 4 CCR section 4181. Which requires the high purity hydrogen grade to both internal combustion engines and fuel cell. So the rationale here is that we would like to enable use of the same fuel infrastructure for both combustion engines and then fuel cell, and then avoid potential contamination issue of low purity hydrogen potentially contaminating fuel cell. Third, for the off-road in-use testing program, we would adopt a work-based procedure for calculating emissions as opposed to the CO2-based method used in diesel engines. And then the reason is simply because hydrogen fuel is carbon-free. It doesn't have carbon. So alternate method is needed. We are requesting feedback, especially on the second point. If low purity hydrogen fuel is desired, Please provide feedback on how it does not result in additional need for fueling infrastructure and cross-contamination. Regarding potential requirements for SCR inducement, it is to be determined at this point, and potential strategies include alignment with US EPA's guidance released of August 2025, or alignment with EU Stage 5 SCR inducement schedule, or something else. So we were requesting feedback on potential strategies for SCR inducement. Okay, so we already discussed useful life warranty defect reporting in the previous workshop, and then we previously considered lengthened year periods in useful life and warranty for Tier 5 interim as well, but we now consider applying them for Tier 5 final only. Defect reporting and corrective action thresholds will be based on California production volume for Tier 5 interim and Tier 5 final to account for low sales volume only in California. Okay, so the next element is marine compression ignition engines less than 37 kilowatt. So currently, Tier 2 standards for propulsion marine CI engines below 37 kilowatt remain in effect in California, while marine Tier 3 standards are in effect for federal standards, and we are considering solving this inconsistency. The requirements for 2031 and later model year marine CI engines below 37 kilowatt largely would align with the federal requirements in CFR Part 1042. And marine engines include propulsion marine engines and integrated auxiliary marine engines. Credits may be generated or used according to the federal requirements. Okay, so staff is also considering several relief options to provide additional compliance flexibility for non-profit labor union organization that provide training on the use of off-road in-use diesel equipment. And then these fleets are currently not exempt, but they can follow the less stringent small fleet requirement regardless of the actual fleet size. And staff is exploring several relief options. Options include exemption from certain requirements for these entities. Okay, so we are requesting feedback on everything, including all sections of the draft regulation order and the draft test procedures. Here we list some of the specific elements we are requesting feedback. So regarding Tier 5 interim optional, is there any concern about the stringency of Tier 5 interim, considering that it is optional? And then we are considering tying Tier 5 interim to incentive funding to incentivize optional standards. What concerns are there? How best can manufacturers be incentivized to bring Tier 5 interim engines to the market? Regarding engine dynamometer aging hours, if alignment with the current federal requirements is desired, please share feedback on why shorter engine dynamometer aging might be considered beneficial. For hydrogen ICE, if manufacturers prefer to use low purity hydrogen fuel for hydrogen ICE, please provide feedback on how it does not result in additional need for fueling infrastructure and cross-contamination between low purity and fuel cell grade hydrogen fuel. For SCR inducement, we are requesting feedback on potential alignment with US EPA or EU Stage 5 options for the inducement schedule. We are requesting feedback on draft regulation order and draft test procedures by March 4th. Sorry, May 4th. And we request alternatives, so pursuant to California SB 617. We welcome public input on alternatives to the regulatory concept discussed in this workshop. And when you propose alternatives, please include data and data-supported justifications with your alternative. Please ensure the submission discusses the alternative's ability to fulfill the purpose of the regulatory concept as we have presented it. Please submit the associated cost and benefit information and data sources to enable comparison of economic impacts, and also submit clear description of the basis for any cost calculations. The deadline for submission of alternatives relating to economic impacts is March 31st. Alternatives may be submitted to our Tier 5 email address here. Lastly, here are the potential Tier 5 timeline and potential next steps. We already released draft potential regulation order and test procedures on February 5th. Initial statement of reasons, or ISOR, and 45-day public notice may be released early 2027 with possible board hearing date sometime in 2027. With that, thanks for your attention. That's all.
All right. So before we get started with the Q&A, I just wanted to remind folks that we put the links, if you joined late, we put the links to today's presentations in the chat. And then at the bottom of your Zoom screen, you'll also see the Q&A box, so you can type in your questions. We're not responding to those questions in the Q&A chat. We will be repeating them orally because only we can see the questions, the audience can't. So of course we want to make it transparent. So if you have questions, please put them in the Q&A box, not the chat. And then we also have those slides that are posted, as well as all the other materials like the draft reg order that I mentioned in my introduction, as well as the test procedures. So there's 6 documents that are on our Tier 5 website, and there's a 7th, which is the public notice of this workshop. So with that, we can get started with the Q&A.
Perfect. Thank you, Jenna and Shun. So good morning, everyone. My name is Marta Anguiano. I'll be your Zoom moderator for today. We'll be starting off with the written Q&As that we have in the Q&A box. And just as a reminder, if you want to ask a verbal question, please use the raise hand feature. If you are calling in, please use #9 to raise your hand. When it is your turn, I will unmute you, okay? So starting off with the written questions. We have a question from Dave Peich, and Dave has stated, need to be below standard for compliance margin. And Jenna will be taking this question.
Yes. So staff conducted we had a contract with Southwest Research, and we conducted our technology feasibility study for Tier 5. We've hosted 5 public advisory group meetings as separate webinars, and discussed the feasibility, including a compliance margin, which we've built into the standard, where we demonstrated the 0.04. So as part of that, we built in nearly 20 milligrams per kilowatt hour into the standard for achieving it. They also conducted field cycle testing to show that the demonstration engine can meet the potential in-use standards. And we incorporated EMA's test results for low ambient temperature testing. So we have an allowance for that for the in-use testing. So if there is still a concern, please provide us with data and send us an email to our email address that Shun provided. It's tier5@arb.ca.gov.
Perfect. Thank you, Jenna. Now moving on to the next question by Marcus Wolomowski. Marcus is asking, is my assumption correct that an early introduction to Tier 5 final in model year 33 to earn California ABT credits requires OBMD stage 1, while stage 2 is only required from model year 39? Thank you. Jenna will be taking this question.
All right. Yeah, so yes, your assumption is correct. That's our thinking, that at least today, that early introduction of a Tier 5 final, let's say in model year 33, would include whatever the OBD requirements are for that introduction. So the regular introduction would be model year 2036. So since OBMD stage 1 is required, then yes, to get AB&T credits, that's our thinking that it would have to have that OBD requirement.
Perfect. Thank you, Jenna. Moving on to the next question from Dave Peich. What is not distinctly CISI turbines? You mean other ICE like HCCI, correct? This could even mean steam engines. And Shun will be taking this question.
Yes, so the not distinctly SI, not distinctly CI, the language comes from the existing language, and then it is up to executive officer, but typically it means that the other, like for example, natural gas engine, that's spark ignited natural gas engine, and then if it's designed for diesel application, then the executive officer may consider. So, well, I don't know what you mean by HCCI, but it's typically other internal combustion engine, like SI engine.
Perfect. Thank you, Shun. Now for our next question from Michael Stezel. This is a long question, so please breathe. So the question is, the current European Stage 5 emission limits for non-road equipment in the 130 to 560 kilowatt power category is 0.4 grams per kilowatt hour for NOx and 0.015 gram per kilowatt hour for particulate matter. The presented CARB proposal for Tier 5 interim states 0.35 gram per kilowatt hour for NOx and 0.010, so 0.010 gram per kilowatt hour for particulate matter. Why can't CARB adopt the same values as EU Stage 5? This difference in NOx and particulate matter limits might require changes to the current Stage 5 engine installations. This might lower the interest of manufacturers to provide engine installations that are compliant to the optional CARB Tier 5 interim proposal. Shun will be taking this question.
Yes, so thank you for pointing out the difference. And then, yeah, we thought about this. And you mentioned why can't we just take EU stage 5? And then the reason is it's because of the particle number standard. European EU stage 5 has particle number standard, but historically in the US and federal and California regulation has never used the particle number standard because the health effect of particle number is not well established. So since Tier 5 interim is only optional, we didn't want to deviate too much from the historical tradition and then introduce particle number only for optional standard. So we did not, our preferred approach was to set the particle mass standard low to have the similar effect as the EU stage 5, effectively requiring DPF. And then regarding NOx, why we set the slightly lower NOx emission? It is our intent is to avoid unintended consequence of lowering PM at the expense of higher NOx, because there is a NOx PM trade-offs. So based on our analysis of DPF equipped engines, we noticed that those engines are capable of lowering both PM and NOx. So which is why we are considering slightly lower NOx in addition to lower PM emission.
Perfect. Thank you, Shen. So for our next question from Jung-Ho Kim, Jung-Ho is asking if the engine manufacturer has EU Stage 5 certification document. Will CARB accept those engines for Tier 5 interim without any additional requirement? Shen will be taking this question.
So, we at this point, no. So we cannot just simply take EU Stage 5 certification. We need our own certification process. So yeah, they will have to go through certification for California.
Yes, they would need to submit an application just the way you would do today. Some of the information and testing could possibly be used, but that's something that you would need to go over with your CERT staff person.
Thank you, Shen and Jenna. For our next question from Abby Taylor Silva, can you please repost the PowerPoints? I don't see them. Thank you. Kim will be taking this question.
Yeah, I get the easiest question. So yeah, if you look in the webinar chat, I dropped the links to the individual presentations from today. And there'll be 3 presentations. So if you click the top one, that's the one that Sean already presented to you.
Thank you, Kim. So for our next question from Benjamin Hefil, are hydrogen ICEs certified with high purity hydrogen also allowed to use low quality hydrogen during use life of the engine/equipment? Shun will be taking this question.
Yeah, so our preference is to unify the hydrogen purity to the fuel cell grade. As I mentioned in the slide, there's a Title 4 section, TCR section that requires the same fuel cell grade hydrogen for ICE and then fuel cell. And then our desire is to focus the fueling infrastructure resource to high purity one, because if you have bifurcated fueling infrastructure, it could be a waste of resource, and also we don't want accidental cross contamination. So, which is why we are proposing this change. But if you don't think the language is clear, or if you have any other suggestions, please let us know.
Thank you, Shen. So for our next question from Dave Peich, Southwest Research Institute demonstration projects are all lab testing. Any actual in use over long periods, for example, useful life? Shen will be taking this question.
Okay, so it is lab testing, but it does employ the accelerated aging. So after treatment are aged to the equivalent of full useful life, 8,000 hours. Regarding in use, yes, it's still the laboratory testing, but the Southwest also tested on the engine dynamometer, but the off-cycle field duty cycle on engine dyno. We collected data and then constructed the field cycle, token speed field cycle, and then ran it on the engine dyno. So it's not the like a full useful life in use in the real engine, because it would take too much time, and then it was beyond the scope of our project. But we did our best to account for long-term aging and then field operation in the laboratory project.
Thank you, Shun. And then just to add to that, that was the second part of our demonstration, was to do the in-use testing, and that report is on our website as well. You do have to look, and you do have to download the report. So you click on the link when you're on the website, and then it'll come up on the top of your screen. You'll have to download the presentations, the reports, right? That's how you get to them. But anyhow, I digress. So our report on the in-use testing is on our website. And then just to go further into the report, so we, as part of this study that we did with Southwest Research, we developed, I think, 5 to 7 in-use duty cycles in order to test because there were no official ones. And so as part of our data analysis, CARB developed those cycles in-house, and then provided those to Southwest Research, and then they helped us refine those, and then we tested those duty cycles as part of the Southwest Research feasibility study. So it had two components. Just to review again, we did the Tier 5 feasibility for the .04 standard for 56 to 560, and then the second phase was the in-use testing.
Perfect. Thank you, Shun and Jenna. For our next question, the attendee does have two questions, so I'll ask the first one. Once the panelists have a chance to answer that one, I'll move forward with the second question. So Tatsuya Chaya is asking, Tier 5 interim, basic certification understanding. For the interim period, my current understanding is that if a manufacturer continues introducing Tier 4 final engines, annual carryover of existing Tier 4 final executive orders may be sufficient from a procedural standpoint. Also, at the engine family level, it seems possible that Tier 4 final and Tier 5 interim certifications could coexist during the interim period. Will above understanding correct? Jenna will be taking this question.
All right. Yeah. And even this is a two-part question. So basically you're asking for the interim period, if a manufacturer continues introducing Tier 4 final engines during the interim period, then the annual carryover of the Tier 4 final EO may be sufficient. And so really during that interim period where Tier 4 final is still allowed, that's your choice if whether or not you're going to certify to the optional Tier 5 interim standard or the Tier 4 final. So if you've decided to just continue on with Tier 4 final, then yes, you would continue on. And again, you need to work with your cert engineer. So I hope I got the gist of your question. Then the second part of number one is it says that the engine family level, at the engine family level, it seems possible that Tier 4 final and Tier 4 final and Tier 5 interim certifications can coexist during the interim period. Is that correct? Yes, that is correct. They can exist at the same time. It's your choice. The default is the Tier 4 final.
Perfect. Thank you, Jenna. Now moving on to question 2 from Tetsuya Chaya. Tier 5 interim incentive, scope interpretation. Regarding the interim incentive, I would like to better understand whether the incentive is limited to transitions from non-DPF to DPF-equipped engines, how eligibility is defined, either engine family, model year, etc. My intention is simply to understand the framework correctly so that we do not misinterpret the structure.
Sure. Yes, this is a good question. They're all good questions, but just for clarification's sake. And so you're basically asking regarding the Tier 5 interim incentive. And so your question is it just limited to transactions? I'm going to use your wording, transactions from non-DPF to DPF engines, and no, it's not. So we know now people, depending on, or manufacturers, depending on the power category and their design, they produce engines with and without DPFs today. And so the idea is it's not limited to people who are already producing engines with DPF, it's limited to everybody. So to certify as the optional Tier 5 interim, you could already have a DPF on your engine today. We just want you to meet those, you would meet the Tier 5 interim standard. So you're asking, how is eligibility defined? Yeah, it's based on model year, engine family, yes. So I hope I've answered your questions, but you can put another question in the Q&A if I didn't get your intent.
Perfect. Thank you, Jenna. So our next question is from Joshua Ewell. Is CARB considering the applicability of Tier 5 interim and final standards to emergency backup engines? Specifically, are there considerations regarding useful life definitions or durability for engines that operate infrequently? How might Tier 5 inducement affect emergency operations during true emergency events? And Shun will be taking these questions.
Thanks, and we recognize that the true emergency event would require some sort of exemption. So we did build in those some exemption or belief in the language for emergency equipment. So please take a look at the regulation order and test procedure. Then if you have any follow-up question, please let us know.
Perfect. Thank you, Shun. For our next question from Chris McLaughlin, when you reference a useful life of 8,000 hours, is that the expected life of the engine? If so, that number is drastically low for certain operations. Shun will be taking this question.
Yes, so when we say useful life, it's not exactly the same as the actual life of the engine or equipment. Useful life specifically, it's for the certification purpose. It's the time for which the engine has to be compliant. And then there is a hour elements and then year elements. So we do know that some engines are used with much more than 8,000 hours or 10,000 or 12,000 hours, but it can take very long years to get to that hour. So we have to consider both hours and then years. And then for off-road engines, there are a lot of low usage equipment. So for example, sometimes the agriculture harvesting activity may only happen in certain time of the year. So if you require long useful life hours, but those low usage equipment may never reach the hour limit. They may only reach the year limit. So, which is why we maintain the 8,000 hour limit and then lengthen the year limit to ensure that more of the low usage engines and equipment will stay compliant within the considered useful life period.
Perfect. Thank you, Shun. For our next question from Mika Buchanan, did Southwest Research Institute test engines in the 25 through 74 horsepower / 19 to 54 kilowatt range? Did they find that Tier 5 final regulations can be met without the use of an SCR in the horsepower class? Shun will be taking this question.
Okay, so Southwest project did not test in that power category, but instead UC Riverside, CSERT, Center for Engineering Research and Technology, they did the separate project that they attached after treatment to those small engines and then measured the emission reduction. And then the standard is achievable, but we also recognize that the standard, some manufacturer may choose to meet that standard without use of SCR. So actual technology is up to them, but we think that standard is feasible and achievable.
Perfect. Thank you, Shun. For our next question from Paul Marvin, can this presentation be shared via email to attendees? Jenna will be taking this question.
Sure. We can share this via email. If you send us an email request to the Tier 5 email, which is Tier 5, all one word, TIER 5 at arb.ca.gov. Send us an email and we will send you the presentations as attachments for sure.
Perfect. Thank you. For our next question from Carl Axley, for Tier 5 final, will there be any update on the certification fuel regarding sulfur content? Today, 7 through 15 ppm, which affects particulate matter emissions. Shun will be taking this question.
So no, in this rule potential rule, we are not considering changing the fuel requirement for sulfur content in diesel fuel.
Thank you, Sean. From our next question, Christina Kubran is asking, when do you think H2ICE will be allowed to operate on California roads? And what, if any, additional data do you need to allow that? Thank you.
So regarding when, it is up to manufacturers. So manufacturers can already certify if they want. So, and what additional data? Well, they need to go through the certification process with CARB certification team.
Yeah, thanks for that question. Yeah, as Shun said, you can certify a hydrogen ICE off-road engine today. So we're clarifying the requirements and setting some new ones, but today you can certify. So you would need to speak to your certification engineer.
Just one further clarification. So today's workshop is concerning standards for off-road engines. So not, if you're asking what's allowed on-road, that's not totally pertinent to what we're here today talking about.
Yes, thanks, Kim.
Thank you, Shun, Jenna, and Kim for that clarification. Our next question from Dave Peich. Many sections refer to California production volume. Does that mean California sales, or could that mean 50 state, so EPA/CARB certified engines that would include California produced engines that are not sold in California? Shun will be taking this question.
Yeah, so our intent is California produced and sold within California. But well, again, if you think language should need to be changed, then please let us know your feedback.
Thank you, Shun. For our next question from Vladimir Karimov. Would this regulation need to seek an EPA waiver or state implementation plan approval under the CAA? Jenna will be taking this question.
So yes, regarding the 2022 SIP, Tier 5 is already a measure in the 2022 SIP, and they went through their own regulatory process, and that's been part of that SIP for a while now. And then with respect to the question, would we need to seek a waiver? Today, we're not entertaining questions on this topic. So we just have to leave it at that.
Perfect. Thank you, Jenna. For our next question from Bill McGavern. Thanks for moving this rulemaking forward. Reducing emissions from off-road equipment is an essential part of California's plans to deliver healthy air to residents. The reductions in NOx and particulate matter projected from this standard are significant. All delays in adopting this rule have real costs in human health. Jenna will be taking this comment.
All right. Yes. Thank you, Bill, for this important comment. And we agree with you. It's something we've been working on for a while, and we're the reductions in NOx in PM are very important. And as part of the SIP, that 2022 SIP, the projections that are also in our slide deck are estimated to be around at least for the measure is 10.4 tons per day. So we agree with you, and it is very important.
Thank you, Jenna. Moving forward with our next question from Dave Peich. Has CARB estimated potential market impacts on engine or equipment markets because of costs and issues with engineering or other societal issues? For example, reduction in engine types, manufacturers for engines sold in California. Significant effort has been put into hydrogen ICE regulations. However, current light-duty market is actually contracting, and the hydrogen service outlets is not really capable to support hydrogen ORCI across California. The possible switch to electrification and associated aggregate electrical demand include aggregate demand from other CARB electrification programs such as light and heavy duty vehicles, solar ZEE, ZE water heaters, energy needed for conversion of water, methane, ammonia to hydrogen, etc. Jenna will be taking this question.
Okay, there was a lot baked in there, so I'm going to try to address those individually. And it says the first one is, has CARB estimated potential market impacts on the engine equipment markets because of the cost and issues with engineering and other societal issues? And the answer is yes. Through this process, we had initiated a cost study, a contract with our contractor, and spent several years soliciting. We conducted a survey from individual manufacturers, and then they aggregated that data on the incremental costs of Tier 5 final. This will look at not just Tier 5 final, but also Tier 5 interim optional. So I emphasize that because this is the second or the many multiple versions. So we're not necessarily talking about cost in today's workshop, but it's certainly that cost will come out in the SRIA, which stands for the Standard Regulatory Impact Assessment, and that will be published in the summer of 2026. So that's looking at the impacts of the entire regulation. Then you also mentioned significant effort, has been put into the hydrogen ICE regulations. Yes, and we recognize that, and you can certify to hydrogen ICE right now. And then it says current light duty market is actually contracting, and the hydrogen service outlet is not really capable of supporting hydrogen ORICE across California. That's a choice that you would make. So it's not a requirement. So what we're looking at is the potential standards for Tier 5 final for combustion, and it's not prescribing hydrogen ICE. So let's see, you also say, I think it's just a comment, it says the possible switch to electrification and assorted aggregate electrical demand includes aggregate demand from other CARB electrification programs such as light duty, heavy duty, SOAR, and energy needed for the conversion. So yes, we recognize that, and Kim, if you want to say some more on that.
Yeah, thanks. Yeah, thanks for the question and the comments. I did want to know, you're asking about possible market impacts and market disruption, and flagging that one of the elements we need to think about as we're developing rule proposals is the economic impact and the impact on equipment availability in California. And I just wanted to note that's been a huge area of our interest over the last year. And it's one of the, we've been looking at lots of scenarios for what if we did a standard here with this effective date? What would that mean for availability of various equipment types? And one of the reasons we've pushed the proposed effective date for the Tier 5 final standards out so far is in hopes that a future federal EPA would consider aligning with us or doing a similar rulemaking so that those standards could be federally harmonized, and we wouldn't have any situations where manufacturers would have to be choosing to make like a special engine just for California. So thanks for the question. We're thinking about these issues too, and like Jenna said, we'll have a lot more detail in our analysis on that in the SRIA, which we'll be releasing later this year.
Thank you, Jenna and Kim, for answering that question. For our next question from Brianna Johnson, can you please write out the email address we must email for the copy of the presentation? Kim will be taking this question.
This is a lot easier than the previous question. Yes. Yeah, I dropped that in the chat. And again, it's tier5@arb.ca.gov.
Perfect. Thank you. For the next question, Daniel Estepa Ruiz, In the accelerated aging process conducted by Southwest Research Institute, which consisted of an engine bench phase and an aging bench phase, what is the rationale behind aging an additional 16% on the engine bench, given that the representation of 65% useful life is already performed on the aging bench? Shun will be taking this question.
Yeah, so the rationale for maintaining the 30 or 35% is again, for, is again, we are not changing the useful life. We are not considering longer useful life hours. We know that in federal requirements, there is a 1,500 hours requirement, and then our understanding is that those shorter 1,500 hour requirement was justified because of on-road regulation was considering longer useful life hours, significantly, longer useful life mileage and hours. And then, because the useful life was extended in on-road, and then the shorter engine dynamometer hours, and then using the accelerated aging all the way to the full useful life was justified. We don't think the same logic applies here because we are not changing the useful life hours. And then 35% of engine dyno engine is already done in California, so it's clearly, we think it's clearly feasible because it's already done. And then since engine, we are not lengthening the useful life hours, we think the engine aging hours, 35% can be maintained, which is why.
Perfect. Thank you, Shun. For our next question, I do see several clarification questions listed. So from James Talavera, thank you for the presentation. Regarding the study on Tier 5 interim and Tier 5 final engines, has there been any issues where the operation and reliability of the equipment has faltered? For example, crystallization of DEF fluid and clogging of DPF filters. Are these issues being taken into consideration when developing the regulation? Thank you for your time. Shun will be taking this question.
Okay, so if I remember correctly, we didn't have any major roadblock. I'm sure their engineer must have faced some minor issues, but they're expert, and then they handle slight change in the hardware setting or updating their software, but we don't recall any major issues in the demonstration project.
Why don't we take a break from the Q&A chat, and I think that there's someone who's raised their hand, or take all the raised hands questions now.
Perfect, thank you. So once again, just as a reminder, if you are calling in, please use *9 to raise your hand. Otherwise, please use the raised hand feature. It should be at the center of your Zoom screen. So for our first raised hand that we have from Manuel Cunha Jr., I have allowed you to speak. Please unmute yourself and state your name and affiliation, please. Thank you.
First, can you hear me?
Yes.
Okay, great. Well, thank you, Manuel Cunha, president of the Nisei Farmers League, and also have been heavily involved in the Tier 2, Tier 3, Tier 4. Now you have a new engine, Tier 5. First, I have a question of authority, and then I have some questions about the off-road, on-field activity in agriculture. First is, are you required under the federal law to request a waiver under the 209E for allowing to try to regulate a engine under 175 horsepower? Do you have a waiver for that, or is your interpretation you don't need a waiver?
So I can take that question.
Super. Thank you.
So actually somebody asked a similar question, and unfortunately today we're not discussing waivers, so I cannot comment on that today, and I apologize for that. But
oh God. Okay. All right. I appreciate that. Number two, let's talk about the part of number 2 will be part of number 3 question, but is on the field activities, have you performed from Riverside actual on-farm field activities in the various crop elements? Because the filter has, and under the original trucks, the catalytic device or the filter device, I remember, was causing our farmers a lot of havoc, in which equipment was burning up in the fields because of the exhaust system got so extremely hot that it would actually catch wheat fields and sides of roads on fire. So have you done extensive work on different farming activities, from dry farming to tree farming, vegetable farming, and even, let's just use the most driest activity, probably onions or barley or wheat? Have you done that?
Are you asking with respect to a tier 5 engine?
Tier 5 engine. Yeah,
Yeah,
tier 5. Yeah, tier
yes,
4 is fine. Tier 4 has its own issues, but tier 5 I'm talking about.
sure. Yeah, so for tier 5, we have a demonstration engine that we created as part of our Southwest Research technology feasibility demonstration. So that's a lab engine, and it's located in San Antonio, Texas. It has not been attached to equipment. So that's a one only engine, and that's located in Texas. That is not part of equipment now, or it's not part of equipment, period. So the answer is no. We have not tested that in the field, in a field activity.
Then will we have the opportunity to work with your agency, like we've done in the past, to definitely talk and work with you to see that we have to actually have field activities? Okay, that's going to be an ask. Number 2,
Hmm.
do you have an idea yet? And being that you've just given me a little bit more, do you have the idea of that cost of that engine, to develop that engine by the manufacturers, if it's Caterpillar or if it's John Deere, Case, Ford, New Holland, any one of the major ones, right?
Yeah.
Do you have a cost of that engine just to build this engine called Tier 5?
Yeah, that's a good question. And as part of the SRIA, which is the standard regulatory impact assessment, we are and will provide the incremental cost for Tier 5. So because we've made significant changes to our proposal, or our draft proposal that we released this month, we don't have those cost numbers to give you today. However, because we continue to make tweaks to our assessment, but we will be able to give those and release those to the public later on this year in the summer is what our proposal is.
Um, my last question, and all, because I'm taking too much time and I apologize.
That's
Um,
okay.
will we have an opportunity, we in agriculture, the San Joaquin Valley especially, because of what we're doing there with all the tractor trade-up programs and using a lot of Tier 4s, is when would you anticipate to no longer allow us to use a Tier 4? Now, I do
Yeah.
know that you're going to have to get a waiver to tell me I can't, that you're going to change me, but if I voluntarily, if I do like we're doing right today with you folks, when would you say that our Tier 4s would no longer be allowed? And then we go into Tier 5, and then you're never going to touch me again. You're never going to touch me to go to an electric tractor. When does all of that take place? Or is there a timeline yet?
Yeah, I can talk to you about the Tier 4 question. And so this is a manufacturer engine rulemaking. It's not about the in-use fleet regulation. So when I say in-use fleet, I mean the farmers, construction, all those fleets that folks, the users, the operators have. So the in-use fleet program is a separate regulation than the tier 5 rulemaking, right? Those are separate. So tier 5 is not banning engines, it's not banning tier 4, tier 3. That's not the part of this. I know what we're focused, if your question on using tier 4 engines is better addressed and there's no ban on them that I'm aware of through the in-use fleet regulation, and Kim might want to speak to that. So there's that question. Then your other question was whether or not we can provide assurance that we'll never have any other tier beyond tier 5, and that I cannot give you today. I know you'd love to hear that, but again, we're not able to do that, but we can talk about the in-use fleet reg a little bit.
Okay. So
And
you're
if
good.
Kim wants to, I don't know if you want
Yeah.
to hear from Kim.
Yeah, please. I was just going
Okay.
to say, yeah, Kim, please.
Yeah, well, first of all, Manuel, thank you so much for being here, and we definitely hear your concerns. And you and I sort of had this discussion before. We totally recognize that agriculture and many industries in California have had to face a series of increasingly stringent requirements from CARB, and that's difficult to deal with. It imposes cost and inconvenience. It's not easy at all. And the reason this has happened over the years is, of course, we have like the worst air quality in the nation. We have really uh, ambitious targets for reducing pollution in order to make the air here healthy to breathe. And so we're doing everything we can in the realm of what's technically feasible and cost effective to try to get pollution down and make the air healthy for all Californians, including those in the valley. And it does mean that over time we come up with new proposals. So we can't. I understand why you and your members would love to be able to say, okay, if we do this, are we done now? And we can stop worrying about air quality and go back to worrying about growing food for people. Like we totally get it, but we can't. It wouldn't be honest for us to say that 10 years down the road there might be some other proposal that could affect ag fleets. So anyway, I can't give you the answer that you'd like to hear, but I do appreciate and understand where the question's coming from.
Right. And lastly, you both stated that you're figuring out that cost to us, because we don't know what the cost of that engine is yet. And you're working on that, and what that will mean for our businesses, I think will be important. So we look forward to working with you and meeting with you. Thank you.
You bet, Manuel. Thank you.
Thank you. And one thing we might do is, we were really blessed to have the participation from engine manufacturers and many other technical experts as we did the demonstration at Southwest Research, including John Deere. And so maybe, if you guys wanted to explore further, what if any impacts to safety might occur for ag equipment, we'd be very happy to participate in conversations on that with you.
Okay, super. We'll work together. Thank you.
And if I may, speaking of safety or potential hazard, at least we don't expect that there is a physical reason to expect additional hazard because the technology is, incremental change. We are using the same technology that exists for Tier 4, but the Southwest demo made an incremental change. So we don't expect a drastically new hazard. But thank you for your comment.
Thank you.
Perfect. Thank you, Manuel, for your question. Now, moving forward to our next raised hand from Stephen Benaroli. I will give you a chance to unmute. Please state your name and your affiliation, please, before stating your question.
And also before you begin, if you can put in the chat what your affiliation is in the Q&A, we're getting a lot of questions from the same people sometimes, but we'd love to hear what the affiliation is and what company you're from or who you represent. So thank you so much. Go ahead, raised hand person.
Yeah, Jenna, thanks. Hey, Stephen Fenaroli with the California Farm Bureau. I won't mention much of what Manuel mentioned, although he covered, I think, a lot of the same concerns that we have. And I do have a number of questions that I'll end up emailing to the group. I do have a comment and a question though. So I know, about CARB's research on ag activity and the feasibility study that you mentioned, but and I know it says, that tractors spend 27% of their time idling. It doesn't actually address reliability feasibility of tier five. And, in a field, feasible technology is only useful if it doesn't require a dealer and a laptop to reset every time, a sensor triggers. So I would, I'd ask again for CARB to look beyond sensor feasibility and conduct a study on operational feasibility. With that, I guess the one question I do want to bring up today, kind of around this idling time or idling piece, idling is often a safety or necessary for operations, but for a number of reasons, right? Hydraulic pressure and keeping that up, or a front loader running a PTO driven pump. So will the tier five idle reduction rule have a PTO active or a safety bypass that ensures equipment doesn't shut off while it's performing a stationary task?
Uh, yeah, I can speak to that. So yeah, we have automatic engine shutdown override conditions. So we are proposing idling reduction, which involves automatic engine shutdown for idling longer than 5 minutes. But we do recognize that in many cases idling is necessary for various safety reasons. So the activity, meeting the certain criteria, and then operator can override the idle engine shutdown.
Okay.
And then I did want to address your comment on reliability. So that's part of the warranty requirements, and it's not just for sensors, right? So we have warranty requirements that manufacturers are required to meet today, and we'll have those as part of Tier 5, and then also the requirement to maintain compliance throughout the useful life, which is different. That's shorter than obviously the life of the tractor. Those are two different things, as Shun has previously explained. So those would be covered under those two elements. But
Okay.
and you said you had some other questions, and of course we'd love to hear from you. And please just email them to us, or call us on the phone. Manuel has our phone number, and we can set up a meeting as well if you'd like.
Yeah, I think I'm sure between the ag interests, I know that this is it is a very concerning addition that we're gonna have to deal with, and I think there's still a lot of question marks. But I just appreciate the workshop today, and I'll email the rest of the questions I have. So thanks, Jenna and team.
You bet.
Perfect. Thank you, Stephen, for your question. Moving forward to the next raised hand that we have, George Lynn, I will give you a chance to unmute. Please state your name and affiliation.
Oh, sorry. I think I hit the wrong button. I didn't mean to ask a question.
No problem, George. Welcome.
No worries at all. Moving on to our next raised hand, Greg Hayter. You can now unmute. Please state your name and affiliation. Greg, you can unmute if you have a question or comment.
Maybe he hit it accidentally too.
Okay, we will be moving back to the written Q&A. Greg, if you do get a chance and you do have a question, feel free to re-raise your hand. All right.
And I'll just note, folks, that this isn't the only time to ask questions. We've actually received quite a few questions before the workshop via email, and have been answering those as well. So before, during, and after, it works for us too.
Yes, thank you, Jenna. So moving back to the written Q&A questions. from Glenn Amber. So this is a pretty long question, so please bear with me. Am I correct that marine CI engines, particularly below 19 kilowatts, but including below 56 kilowatts, will harmonize with and be subject to the certification levels regulated in EPA 40 CFR 1042 without any further regulation under CARB Tier 5 Final? As I understand it, CARB does not currently recognize EPA 1042, particularly for below 19 kilowatt, and forces marine engines to meet CFR 1039 level emission requirements, like high altitude operation. Most oceans, of course, are at sea level, not high altitude. Shun will be taking this question.
Okay, so what we are presenting here today is the engine certification requirement for marine CI engine less than 37 kilowatt. And then the standard level will harmonize with the one in the with those in the CFR Part 1042. So that's the engine certification emission level. But California may have its own corrective action requirement or in-use compliance testing requirement. So that's a separate requirement. And then regarding the 1039 level emission, so for engine can be certified at 1042 emission level. There may be other EU's fleet regulation that push for cleaner emissions, such as the commercial hovercraft regulation. So that's not what we are discussing here, and then it's handled by another program, and then they might have their own separate requirement. That's all.
Perfect, thank you, Shun. So for our next question from Asad Ghazan, thank you for the presentation. Regarding the study on Tier 5 interim and Tier 5 final engines, has an atmospheric engine been tested or only forced induction? Shun will be taking this question.
Yeah, so the demo engine used the turbocharger, so only forced induction.
Perfect, thank you, Shun. So for our next question from Dave Peich, there was no discussion on replacement or rebuild rules for 2423.1J1G. So I believe Dave is referencing a section in our reg order, or draft potential reg order. The replacement engine checklist requires an equipment SN for a future engine replacement. So I believe a serial number for a future engine replacement. For 2423.1M, rebuilding engines, it specifies any person, such that any or all reporting would require distributors, dealers, owner, or operators to report and label engines that those entities might rebuild. Correct? I know these are two questions, so Francine will be taking this question. Please take them in pieces.
Thank you, Dave, for your questions. Regarding the first one, about replacement engine checklists requiring equipment serial number for future engine replacement. In the draft potential reg order, we are requiring that the equipment be identified, including a serial number for which the engine is to be replaced. This is part of the checklist and clarification to remind manufacturers that they need to investigate whether a currently certified engine would be able to fit in the existing equipment that has the same physical or performance characteristics necessary to repower the equipment. So you would need to know what the equipment is that is needing the engine replacement. So you should have access to the serial number of the equipment. As far as the rebuilding of engines, we are requiring that anybody that manufactures engines as well as rebuilding engines they would need to provide a report as to what engines they are rebuilding. So it wouldn't necessarily include owner operators because don't expect them to be manufacturing engines. Basically, you would have to be a manufacturer as well as providing rebuild services. Thank you for their questions.
Perfect. Thank you, Francine and Dave, Dave, for that question. For our next question from Candice Youngblood. Thanks for the presentation. Doesn't the rule have in-use components like in-use testing requirements? Jenna will be taking this question.
Sorry about that. Took myself off mute. All right. Yes, that's correct. We do have in-use testing requirements for manufacturers. So these are new requirements, and we're going to be, or new potential requirements, and we're going to be discussing that after we finish this Q&A. We have a whole presentation on that topic, but I think your question may be tied into, I'm guessing, to my past comment on the in-use fleet. So it's not for the users. This in-use testing requirements is not for fleets, it's for manufacturers. So, I appreciate that, and we've got the whole presentation that will cover it. So we'll hold off on giving any more detail on that. Thank you.
Yes, thank you, Jenna. And just to clarify, for the future presentations we will be holding, Kim did put the links to those presentations in the chat. So please follow along with the presentations once we hold those. For our next comment from Johnny Seliznov, Johnny did comment your affiliation of Innovative Ag Services in Hanford, California. Jenna was going to take this comment.
Yeah, I think he was probably just letting us know where he's from. So thank you so much, Johnny. Appreciate that.
Yes, thank you. Moving on to our next
Actually,
question.
Martha, sorry to talk over you. So if other folks who are typing in Q&As, and by the way, awesome questions, really appreciate all these and how much you guys have already thought about our proposals ahead of here, obviously. But if you could please put your affiliation in the question, that would really help us understand the context of your questions better. So thank you.
Yes, thank you, Kim. So moving on to our next question from Rebecca McIntyre. This is a pretty long comment, so please bear with me here. How much time and effort does CARB spend on worldwide regulation harmonization? I see references to EU Stage 5 as well as US federal regulation. My question isn't so much about if you know other regulations. I'd like to understand how CARB works with other agencies to achieve synergies and regulations, and would like to understand the effort taken to work with other agencies to streamline regulations, as most equipment manufacturers desire a product that meets certifications worldwide. For example, China, US, Europe, etc. In a single product, it is unrealistic to assume a manufacturer is only designing a product for just California or just for the United States. Jenna will be taking this question.
All right, this is a wonderful question, and I so appreciate this. So as I started in my introduction, this is really our coming up on our 5th year of working on Tier 5. It's our 10th public meeting, and during these 5 years, we're working behind the scenes, and we have met twice with our Chinese counterparts. We also meet with the EU folks many times and met with them in person, and look at other countries' standards. And you mentioned EU, and that's part of our huge analysis that we did last year on comparing Tier 5 interim standards, which we actually had looked at and were much more stringent a couple years ago. And one of the comments, many comments from stakeholders was, would you consider harmonizing the interim standard with EU Stage 5 like standards? So we spent many months analyzing that, looking at the emission reductions, and also speaking with many engine and equipment manufacturers to talk about the EU Stage 5 like standards, because harmonization is important to us. And then additionally to that, we meet regularly with US EPA and talk about the elements of Tier 5 and what we're thinking about, and um, having excellent discussions with them and getting their feedback as well. So we're doing all these things behind the scenes. And then several years ago, just to talk about our EPA collaboration, we spent a week in the Midwest, my team, and US EPA, and we toured 5 manufacturing facilities, and our EPA counterparts came on those tours with us. In fact, at one point there were more EPA staff than CARB staff, which was wonderful. It was a wonderful experience for all of us. So, and the agencies worked with Canada as well. So we are working hard to think about harmonization in for manufacturers, and taking that into account when we roll out these draft potential standards. So I appreciate I appreciate your comments, and we've really tried to be responsive. Um, and that's why we're introducing this optional Tier 5 interim, because we are aware of costs, and just designing a product for the California market. And that's why we've built in more time for manufacturers to implement Tier 5 vinyl in model year 2036. So thank you for the question.
Yes, thank you, Jenna. For our next question from Dave Peich, I believe he has a follow-up question. How do I know the future equipment serial number for an engine that has not yet but may fail? Francine will be taking this question.
Hi, Dave. Again, the replacement engine allowance is specifically for equipment that needs a replacement engine. So you would need to do your due diligence and checking what that equipment may need. I mean, the checklist is to be filled out at that time. That is to go step by step through the process of examining the equipment, checking which engines may fit. So again, you would need to know the equipment, which is going to be receiving that engine. And you would fill out that checklist each time a replacement engine is needed. Those checklists would not be required to be submitted at that time. The replacement engine that process would be done in identifying which engine would be needed for that equipment. And the checklist would then be submitted at the end of the year once you know which pieces of equipment are receiving these engines, and you're reporting how many engines were produced and delivered to California as replacement engines. So you wouldn't need to know initially all the information at that time, but you do need to keep records of those checklists, make sure they're properly filled out, and submitted at the end of the model year to report the number of replacement engines produced and delivered for California. Thank you.
Perfect. Thank you, Francine. Thank you, Dave, for that question. So I believe that does conclude our Q&A for this first presentation.
No other hands raised.
No other hands raised.
All
No.
right. So what I propose is that we said we would start, a little bit later, and for the off-road in-use testing presentation. And since we're a little bit ahead of schedule and we've had nearly 2 hours without a break, I suggest we just take a 15-minute break and for everybody to just refresh themselves. And why don't we come back at 10:30? We'll leave our screens on, so it's 10:17 right now, and then we'll come back at 10:30, and then Dr. Hanwei Zhu will present on the off-road in-use testing. All right, thank you, everybody. We'll see you at 10:30. All right, it's 10:30. Welcome back. I'm glad we got a chance to take a little break for a few minutes and get some water and a quick snack, and stretch if you did that. Okay, well, the next part of our program is the off-road in-use testing section, and Dr. Hanwei Zhu is going to present this part of the program. So again, we have the Q&A chat open, and so you can type in your questions into the Q&A box, and we'll get to them after the presentation. And you can also raise your hand at the end as well. So with that, I'll let Hanwei start up his presentation, and we can see it, Hanwei. Thank you.
Thank you, Jenna. Hello, everyone. My name is Hanwei Zhu. I'll talk about the potential changes to the off-road in-use testing program. Here's the outline for this presentation. We'll give you some background information on off-road in-use programs, and then provide a summary of the potential changes for Tier 4 in-use compliance program, or IUC, and Tier 5 in-use testing program, or IUT. Then we'll dive into Tier 5 or IUT program and focus on two major components, ECU sensor data screening using onboard sensors, manufacturer run in-use PAMS testing. For each of these components, we'll discuss the feedback we have received since 2024 workshop and the potential changes we drafted this time. And lastly, how stakeholders can provide their feedback. Some background information for off-road in-use programs. The purpose of off-road in-use programs is to ensure off-road engines meet emission standard under real-world operating conditions, and that engine family complies throughout their useful life. For Tier 4 engines, we conduct in-use testing under the CARB run off-road in-use compliance program. For Tier 5 engines, we're introducing a manufacturer run or IUT program for the first time, and this program applies to Tier 5 engines families ranging from 56 to 560 kilowatts. It includes two major components, ECU sensor data screening and manufacturer run in-use PAMS testing. And since the last workshop, we have received extensive feedback from the stakeholders and drafted potential changes for both Tier 4 and Tier 5 test procedures. First, we want to summarize what the potential changes are for the Tier 4 CARB run or IUC program. And these changes will apply to new model year 2031 and subsequent years for all power category for Tier 4 compression ignition engines and marine compression ignition engines that are less than 37 kilowatt. The main purpose of these changes is to clarify the language for the Tier 4 or IUC program, especially on the testing method and engine family pass-fail criteria. For the testing method, we clarify that the NTE provisions will apply for all these engines, and we have incorporated the relevant NTE sections from CFR Part 86. And for engine family pass-fail criteria, we clarify that we will start testing with 5 engines per engine family, and if 2 or more engines in an engine family fail the engine pass criteria, then we will test up to 10 engines. And if 3 or more of 10 engines fail, the engine family is considered fail, and it will be non-compliant. And this approach is generally consistent with the CFR Part 86 provisions. Moving on to the Tier 5 in-use testing program, there are several potential changes we want to talk about here. For emission evaluation, we're considering selecting a two-beam moving edge window method for NOx emission evaluation for both the screening program and PAMS testing. for ECU sensor data screening, we're considering setting a less stringent threshold. We're also considering incorporating the adjustment factor to account for sensor measurement bias. And lastly, we have considering removing the pilot program. And lastly, for PAMS testing, we're considering to reduce the testing burden by limiting the PAMS test orders to 25% of the number of large sales volume engine families. And we're considering to introduce low ambient temperature correction factors to account for equipment which are operated in a cold environment. And we're also considering to remove the interim margin from the in-use PAMS NOx emission scratch threshold. And we're considering to relax the requirement for small and very small sales volume engine families. Next, we'll dive into the Tier 5 ORIUT program and talk about ECU sensor data screening first. To begin with, we want to give you an overview of the ECU sensor data screening and let you know how the results from the ECU sensor data screening will help determine if a specific engine family could be exempted from PAMS testing. As you can see from this flow chart, a manufacturer will start by submitting screening data for at least 75% of the engine per engine family each year to the EO. EO will assess the data and check if the NOx and PM criteria are both met for each engine family. If both NOx and PM criteria pass, the engine family will be flagged as clean engine family and exempted from PAMS testing. Otherwise, they will be flagged as dirty engine families. I do want to note here that the dirty engine family doesn't mean that this engine family is high emitting or even emission non-compliant. It just means the engine family will be flagged for potential manufacturer run in use PAMS testing. And then a compliance determination will be made after the PAMS testing. I also want to note here that we haven't made any changes to the PM criteria for ECU sensor data screening, so this presentation will mostly focus on NOx. Following the overview of the screening program, we'll talk about what feedback or comments we have received so far since the last workshop in 2024. And we'll also talk about what changes we made in response to those feedback. One comment we received from a stakeholder is about the minimum reporting requirement. And the stakeholder is concerned that the requirement is too strict and we have not considered the unforeseen operating conditions for off-road equipment, such as those are operated in remote location, which don't have wireless connection or satellite connection. We really thank stakeholder for providing this feedback. We have revised the test procedure to allow the engine manufacturer to submit data for less than 75% of the engine per engine family, provided that the engine manufacturer should notify the EO and receive approval. And this approval will be based on if manufacturer demonstrating that the submitted data is representative of the engine family, and providing enough justification for all the missing data. Next comment is about data submission frequency. The stakeholder is concerned that the data submission are too frequent. We thank stakeholder for their comment, and we consider sensor data screening less effective at identify those high emitting engines if the data submission frequency is too low. Even 3 years would significantly postpone PAMS testing and could possibly cause excessive emission to occur for too long without being caught. Moving on to the next feedback about requirement for very small sales volume engine families. There are concerns with my manufacturer that there are a lot of challenges in sourcing the test articles for very small sales volume engine families. And we also have conducted some in-house analysis and reevaluate the requirement for very small sales volume engine families. According to our analysis, this category contributes to less than 5% of the overall emissions, We are re-evaluating it and considering relaxing the PAMS testing requirement for very small cells engine families to prioritize those testing resources. Now you can see from the table here, we revised the PAMS testing requirement for those very small cells volume engine families to be optional. Moving on to the next subject about the moving average window method. First, I want to give you a brief introduction to the moving average window method. This method is used to evaluate emission performance by averaging the emission data over 300-second windows and grouping them into different bins. And depending on how the data is segmented, the method is characterized as either 2-bin moving average window or 3-bin moving average window. As shown in this table, both 2-bin mall and 3-bin mall methods share the same bin A, which is idle bin. And the difference is really the bins B and bin C. The non-idle bin for 2-bin moving average window method is essentially a combination of bin B, low bin, and bin C, high-low bin in the 3-bin mall method. In 2023, we introduced a torque-based 3-bin moving average window method to assess the in-use NOx emission using onboard sensors. Stakeholders have provided valuable feedback, including, first of all, the minimum window requirement. Stakeholder is concerned that meeting the minimum window requirement for bin B and bin C will be challenging for some off-road applications, since some of those applications may mostly be operated in either bin B or bin C. And another suggestion by stakeholder is that the 2-bin mall method could be equally as effective in identifying the high-emitting engines compared to a 3-bin mall method. Given the feedback we received from the stakeholders, we have reevaluated the 2-bin mall based on the latest finding from the off-cycle testing contract with Southwest Research. And the project demonstrated that the 2-bin mall is equally effective at flagging those higher emitting engines. And it also demonstrated that the 2-bin mall increased the likelihood of meeting the minimum window requirement within a single day testing. So we're considering selecting the 2-bin moving average window method as the NOx emission evaluation method to kind of align with the US EPA. Moving on to the next subject about the sensor accuracy margin for sensor screening. In 2023, CARB staff introduced a sensor accuracy margin to account for measurement error between the onboard NOx sensors and 1065 compliant laboratory instrument. To support this effort, Southwest Research conducted a 2-year CARB-funded study to evaluate the performance of the onboard NOx sensors. And in this project, Southwest tested 9 different sensors from 3 different sensor manufacturers. And all the sensors, they were aged for at least 800 hours. And in addition to all those data collection phase, they have also developed a correction algorithm using the existing sensor data from both on-road and off-road application. And the results show that the algorithm significantly improved the sensor performance, especially at the low NOx concentration, where typically NOx sensors are struggling at. And following the development of those the sensor correction algorithm, the sensors were also evaluated under 7 different in-use test cycles using the Tier 5 demonstration engine. And with all those sensor data we collected, CARB staff were able to conduct some in-house analysis to determine NOx sensor accuracy margin for bin A and bin B. Now, as you can see from the left-hand side figure here, this histogram shows the distribution of sensor error compared to lab measurement in unit of gram per hour for bin A. And each data point here represent one sensor tested under one specific real-world off-road duty cycle. And this data analysis we did accounted for all those different variables which could affect sensor performance, such as the sensor technology, production variability, sensor aging, different duty cycle, and even ammonia interference. So from this histogram, we estimate the sensor measurement error for bin A, and this is after applying the correction algorithm. The positive offset is around 0.04 gram per hour, and the standard deviation is around 0.18 gram per hour. So we're considering a sensor accuracy margin for bin A of 0.2 gram per hour, which cover over 85% of this distribution. And we're really interested in any feedback from stakeholders on this margin. If there's any suggestion, don't hesitate to share your thoughts and your rationale with us, and along with some supported data. We have also estimated the sensor measurement error for bin B, and this is also after applying this correction algorithm. The positive offset is around 0.02 gram per kilowatt hour, and the standard deviation is around 0.016 gram per kilowatt hour. We're considering a sensor accuracy margin for bin B of 0.036 gram per kilowatt hour. Again, we're very interested in the feedback from stakeholders on this margin. Excuse me. If there's any suggestion, please share with us, including the data. This slide basically summarizes the draft potential NOx emission screening threshold for the two-bin mall method. The thresholds are calculated as the conformity factor times the emission standard. For bin A, the emission standard is the idle standard, and for bin B, it's the weighted average of the NRTC and LLC standard, and plus a sensor accuracy margin. And conformity factor is set as 1.5 for criterion 1 and 2.0 for criterion 2. And we'll talk about those two criteria in the next slide. Yeah, so the previous slide explained the pass criteria for each individual engines, and this slide focuses on the engine family pass-fail criteria. This slide we have discussed in the last workshop, and I want to go over with you. Here is how an engine family is identified as clean. For NOx emission in particular, a clean engine family must meet both the criterion 1 and criterion 2 for both the stored 50-hour array and the lifetime array. Basically, criterion 1 assess the average NOx emission across the entire engine family, and criterion 2 mostly focus on the percentage of engines within that engine family that are either high emitters or that are no reported data. And since the last workshop, the stakeholder indicate those pass-fail criteria need some further clarification. In response, we have provided an example in the following slide to show you how this criteria will be applied. Let's take an example here, considering a 187 kilowatt variable speed engine, and the NOx emission threshold for criteria 1 for bin A is calculated as the conformity factor of 1.5 times the idle standard, which is a function of engine power. For a 187 kilowatt engine, the idle standard is 10 gram per hour, and plus a sensor accuracy margin of 0.2 gram per hour. And for criteria 2, simply replace the 1.5 with 2.0. So for bin A, criteria 1, the NOx emission threshold is 15.2 gram per hour in this case, and 20.2 gram per hour for criteria 2. And please note that there was an error in the posted slide, and the red font here indicate that the edit we made. The threshold for criteria 1 for bin B is calculated as the conformity factor times the weighting average of the 75% NRTC and 25% OR LLC, and plus a sensor margin of 0.036 gram per kilowatt hour. For criteria 2, simply just replace 1.5 of conformity factor with 2.0. So in summary, the NOx emissions threshold for beam B is 0.104 gram per kilowatt hour for criteria 1 and 0.126 gram per kilowatt hour for criteria 2. And moving on to the engine family pass-fail criteria, we also want to give you an example for beam B emission evaluation here. Now we're giving this example only for large cell volume engine families because the sensor data screening, like we said before, is optional for small and very small ones. And the table here shows you in total 4 different example engine families. They're evaluated based on 3 different parameters, as you can see from the top title here. Reporting rate, which means the percentage of engines in the engine family that submitted data. And the pass threshold is greater than 75% of the total CA sales volume. For criteria 1, this means the average NOx emissions for beam B compared to the screening threshold. And the pass threshold in this example is less than 0.104 gram per kilowatt hour. And then I want to explain criterion 2 very carefully here. Criterion 2 is the combined percentage of unreported and high-emitting engines, and the pass threshold is no greater than 25% of the total CA sales volume. And if you look at the example here, engine family 1 passed all the criteria and it is exempted from manufacturer run in-use PAMS testing. Engine family 2 failed criteria 1 because the average NOx emission exceed the threshold. So it will be flagged for potential PAMS testing. And engine family 3 failed criterion 2 because the percentage of high-emitting engines exceeding 25% of the total CA sales number. Engine family 4 also failed criteria 2 because the reporting rate is too low and most of those unreported engines don't meet the special conditions such as the remote location or low usage. So engine family 1 will be exempted from PAMS testing, and engine family 2 through 4 will be flagged for potential manufacturer and use PAMS testing. And please note that all these examples, they're really for illustration purpose only. And we hope all this example will help you kind of understand the screening process in terms of how to identify the engine family that may need further PAMS testing. The last change I want to mention to sensor screening is the pilot program. We have reevaluated the need for a pilot program because the implementation start date for Tier 5 final will be model year 2036, providing the manufacturer with additional time for research and development. And also, there will be no onboard diagnostic requirement for Tier 5 interim engines. So as a result, we're considering removing the ECU sensor data screening pilot program. We'll then talk about the second part of the ORIUT program, which is the in-use PAMS testing. First, we want to talk about the feedback and potential changes. Stakeholders expressed concern that requiring PAMS testing for 25% of the engine family was too burdensome, and some off-road programs should not be compared to the on-road or on-highway programs. In response, staff is reducing the burden by limiting the PAMS testing to only large volume engine families that have a greater emission impact. And the current draft potential test procedure stated that the annual test order will not exceed 25% of the annual number of large volume engine families certified over the past 4 years. Give you an example here. If a manufacturer has 8 large sales volume engine families on a single year, they will test at most 2 engine families. So this approach will help provide you more feasibilities for manufacturers. Stakeholders also request more flexibilities in finding test articles for those off-road equipment. We really thank stakeholder for this feedback. We recognize these challenges, and we're considering allowing manufacturer to request modification to the requirement or select a different engine family as long as they're approved by the executive officer. And we believe this change will help you, provide you more flexibility in the testing. Another question from stakeholders was whether PAMS testing should include PM, given that on-road PAMS testing exclude vehicle with malfunction DPF. Staff do think that PM testing is necessary because in general, PM is still considered as an air toxic, and sometimes excessive emissions can occur even without triggering a malfunction light. So, for example, a degraded DPF may not trigger false code, and could still lead to increased PM emission. So we think this test will still help ensure that those PM emissions remain within the limit throughout their useful life. Staff is also considering using the same tubing mall method for PAMS testing that is used for ECU sensor data screening. However, for PAMS testing, the tubing mall method will only apply to all criteria pollutant and not just the NOx for the screening. And during the PAMS testing, stakeholders raised concern about accounting the effect of low ambient temperatures. We do recognize that, and we reevaluate this issue, and we develop adjustment factor, and we'll discuss that in the next couple of slides. Cold temperature could affect the tailpipe NOx emissions, and in order to study the actual impact of the cold temperature on emission performance, Southwest Research conducted a test funded by EMA on the Tier 5 demonstration engine. And this testing includes a different engine and after-treatment system, and include different wind conditions and different duty cycles, which at the temperature ranging from 3 degrees C to 28 degrees C. So the result shows that the low ambient temperature can increase NOx emission under certain configurations and cycles, and the worst case temperature effect on the EMA fuel cycle 2 were observed for the child rating engines, and NOx emission in bin A increased from 0.12 gram per hour at 27 degrees C to 2.2 gram per hour at 3 degrees C. Similarly, bin B emission also rose from 0.03 gram per kilowatt hour to 0.079 gram per kilowatt hour. And the off-road low-load cycle was also tested in this study, but we do think that although the low-load cycle had a higher emission than the fuel cycle 2, the fuel cycle result would be more relevant and representative because the low ambient temperature are only encountered during the fuel cycle testing. So based on those testing results, we developed a correction factor for PAMS NOx threshold when the temperature fall below 20 degrees C. And for bin A, the equation to calculate the correction factor is 20 minus the ambient temperature in degrees C and times 0.122 gram per hour. And for bin B, the slope becomes 0.00288 gram per kilowatt hour. And those slopes were developed based on the linear fitting of the data from the 3 degrees C and 27 degrees C. And we do believe this developed correction factors will help account for the possible increase in emissions under these cold conditions. And moving on to other feedback for in-use PAMS testing, another question raised by a stakeholder is whether failing a PAMS testing will automatically trigger recall. The answer is actually yes. If an engine family failed this sum over sum emission threshold, and the manufacturer will take corrective action under the CCR section 2113 and 2125. And the corrective action may include recalibrating the engines, replacing defective parts, or taking other measures to reduce the emissions. Another change staff is considering is removing the interim allowance for PAMS testing. The interim allowance was originally set to account for emission measurement technology advancement during the interim period. And because Tier 5 interim for model year 2031 to model year 2035 are optional, and our draft timeline for Tier 5 final implementation start with model year 2036. We believe that this will provide manufacturer sufficient time to continue the technology development and prepare for emission compliance. Therefore, we're considering removing that interim allowance. Based on the feedback from stakeholders we discussed previously and our reassessment, and here we kind of summarize the updated draft sum over sum threshold for PAMS testing, and the equations are listed in the table. So the threshold are calculated by a conformity factor of 1.5 times the emission standard. For PAMS being A, it's going to be the idle standard, and for PAMS being B, it's the weighting average of NRTC and LLC, plus a PAMS accuracy margin, and also plus a low ambient temperature adjustment factor. I want to give you another example here. Again, for this 187 kilowatt engine at 20 degrees C, so the NOx emission threshold for being A is 15.4 gram per hour, and for being B is 0.075 gram per kilowatt hour. And lastly, we invite stakeholders to provide feedback on all the aspects of the draft proposal. Specifically for ECU sensor data screening, we're seeking feedback on NOx sensor accuracy margin, reporting flexibility, and removal of the pilot program. For PAMS testing, we're seeking feedback on removing the interim allowance, the 25% cap on large volume engine families, the criteria for selecting test articles, and the development of the low ambient adjustment factor. Our email address for the comments is tier5 tier5@arb.ca.gov. So we think stakeholders' input is critical to finalize these test procedures and ensure all those are effective. And thank you so much for your attention, and I'll take questions.
Perfect. Thank you, Hanwei, for your presentation. So we will be opening it up for the Q&A written questions and the verbal questions. Once again, please state your name and affiliation, whether that's in the Q&A box or if you will be asking a verbal question. So to start us off, we do have a question from Kevin F. Brown. Slide 20 of the OR-IUT presentation needs to be updated in the downloaded version of the presentation. The current is not up to date and may cause future confusion. Jenna will be taking this question.
Yes, thanks, Kevin, for your question. Yes, we are aware that the slide deck that's on our website, it does not have these corrections that Hanwei's gone over, or the one that Shun identified during his presentation, and that was intentional. We wanted to make sure that we didn't find any other edits that needed to be done, and so we could correct them all at once. And so after the workshop, we plan on issuing an errata and add those corrected slides, and that will be posted on our website. So thank you.
Perfect. Thank you, Jenna. For our next question from Dave Peich, the regulations are being adopted to address the California State Implementation Plan requirements, correct? Please identify how many NOx or ozone exceedance days have occurred in California at 3 degrees Celsius or 37 degrees Fahrenheit, or even below 20 degrees Celsius / 68 degrees Fahrenheit. Shun will be taking this question.
Hi, thanks. So the first one, yes, this is part of the state implementation plan. That's correct. And then regarding the ozone exceedance at low temperature, we don't have the exact number handy at this point. And then, thanks for the question. But I just want to point out that the ozone pollution is not just a summer problem. Of course, yeah, summer can be, there can be a tough, ozone exceedance in summer days, but it can also happen in winter days. So it's not just a summer problem. And then the SIP, the emission reduction in SIP is targeted as the annual reduction. So that's we are doing. We're not distinguishing summer emission and annual, winter emission. And then also last point is that the low ambient temperature correction approach is taken by US EPA for on-road regulation already, and then we are using a similar approach. And also we are adding that low temperature allowance as a function of temperature. So that's already done by US EPA, and we're taking a similar approach. Thank you.
Thank you, Shun, and thank you, Dave, for your question. For our next question, from Tatsuya Chaya. I believe there are several questions embedded in this. Please bear with me. So the question is on Tier 5 final in-use versus OBD timing alignment. We would like to confirm our understanding regarding the timing alignment between the in-use, off-road in-use testing provisions and the OBD requirements. For NOx of off-road wheel data functions, both appear to apply beginning in model year 2036 under stage 1, so we do not see a timing issue there. However, for particulate matter filter related fault data storage, or IUT appears to apply starting in model year 2036, while OBD stage 2 under section 2422E 3F1 begins in model year 2039. Could you please clarify how CARB intends these provisions to align? And the second question is particulate matter fault data storage expected beginning in model year 2036 for in-use compliance, or only once OBD stage 2 formally applies in model year 2039? I believe Paul will be taking part of this question.
Yes. Hello, can you hear me?
Yes.
Okay, good. Yeah, I'll just confirm the OBD piece of this, which is that the PM fault code tracking aspect of the OBD requirements does not start until stage 2, which is 2039 model year. So that is correct, and that's going to coincide with when diagnostics start to be required. So Jenna, I'll let you address the other part.
Of course, and then the question, just to reiterate, it says, we'd like to confirm our understanding regarding the timing alignment between the in-use, the off-road in-use testing provisions and OBD requirements. And yes, we are aligning with them. That's correct for the NOx real data functions to appear and apply. They both start in model year 2036. So you're right, there is no timing issue.
Perfect. Thank you, Paul and Jenna. Moving on to our next question from Dave Peich. For section 4.1 or section 1036.410 requires the engines to be properly maintained. What information denotes properly maintained? A logbook meeting all manufacturer recommended maintenance. If there is no logbook or information, can the engine be excluded? Hanwei will be taking this question.
Yeah, I can take the question. So the question is about what information denote properly maintained. I think for that part, generally, manufacturers should follow the logbook, for maintenance. And if there is no logbook or information, we do have provision like allowing you to request for modification as long as you all approve for it. So that will be a case-by-case evaluation.
Perfect. Thank you, Hanwei. And so we do have another follow-up comment or question from Dave. Engine manufacturer and use testing requires cooperation with equipment manufacturers and especially owners or operators. Requirements for discrete CARB sales data will be problematic for engine manufacturers selling to OEMs who can't or won't share their data with the engine manufacturer. This is especially an issue for non-integrated engine or equipment manufacturers.
I can try to answer this question. So the question is about what if the engine or equipment manufacturer is not vertically integrated, and then the engine manufacturer may end up working with the equipment manufacturer on that. So yeah, we do have provisions like fall into the special conditions, like if there is a special case, like you're not able to, engine manufacturer will not able to get screening data, either due to remote location or due to consumer won't allow it, won't be able to share it, or due to equipment manufacturer won't be able to access those. Any of those are going to fall under the special provisions, and those will need you to submit the basic justifications in the screening plan, and we can, after EO's approval, then it will be on a more like a case-by-case evaluation again. Thank you.
Perfect. Thank you, Hanwei, and thank you, Dave, for your questions. So those are all the written questions we have for now. So I'll pass over to any raised hands that we have. So the first raised hand we have is from Andrew Matthias. So I will allow you to unmute yourself. Please state your name and affiliation once you're able to unmute. Andrew, you can unmute now if you have the chance. You're unmuted, but I'm afraid I can't hear you. If you're experiencing technical difficulties, I can revisit your raised hand. Okay, moving forward to our second raised hand from Manuel. Once again, please state your name and affiliation. You can unmute.
Can you hear me?
Yes.
Okay, great. Thank God that I have young staff to help direct this little tech world. Christ. You guys are putting me through quite a pressure here. Really are. You're adding years to the life. Thank you very much. I have somewhat of a more, I have a simpler question tied to this, but I noticed throughout the entire 1 and 2 is the idle time that was brought up earlier. And we've always had that discussion, and we had a big discussion with our farm equipment on idling, because our equipment has to idle when it's in an orchard picking fruit with a bin trailer. It is going to idle. It has to. It cannot be revved up at 2,000 RPMs or whatever. So we're going to have a question about that. Secondly, the issue of temperature is different on an on-road versus a farm. And I think that is a question that we need to make sure. Our concerns is that this engine cannot be shutting down, and that fruit suddenly, and that tractor can't be pulled out of that orchard because the sensors tell it to shut down, and the guarantee of the manufacturers. And that's why I go back to my question earlier this morning. You have an engine in Texas and you have an engine in Riverside, and I don't know what I've been told through the grapevine that you have 2 engines in the San Joaquin Valley on farms. and one of those engines I think has failed. But in saying that, are we going to have that real activity that applies to the farm? I don't really care about, in a sense, about the on-road, because you're going to have to deal with trucks and et cetera, et cetera. So you got a big responsibility there, but it's a total different environment. On my farm, I do have, a couple weeks ago, we were down at 19, 20-degree temperatures. In 1990, we had 7-degree temperatures in the valley here in our farm. So I just have this fear that your sensors are gonna shut my tractors all down, tier 5s that we may have. And now I've got fruit rotting in an orchard because I can't pull the tractor out. The tractor shut down on the avenue because it was told that it wasn't idling high enough. So my concern is that I would hope ARB, in its ability that at Riverside, though, is Riverside. It's not my farms, our farms. So I'll stop there if that makes sense what I'm asking.
If I may, I can speak of idling first, and then so we, in our concept, first idling has option. So first option is to make sure idle emission is clean. So if the if it's clean, then it can keep idling because we have no concern. And then if manufacturer choose the option of introducing engine shutdown, then the engine will be programmed to shut down after a certain time. But we recognize that the idling is necessary for many cases, so we have built-in override condition. So if you're interested, please look into our test procedure, and there is a automatic engine shutdown and override condition. We listed theirs, and then if you have any suggestions, please let us know.
Okay, I'm going to throw it back into your court, young man. I'm not going to go in and I'm not an engineer, I'm not a mathematician, but I want you to tell me and come to me in my valley, and then you tell me upon the questions and the conditions we have. If a manufacturer is going to produce a tier 5, they're not going to produce a tier 5 that's going to produce emissions. It has to be designed to idle, and you have to understand my conditions. So I would appreciate it that you come to me. I'm not going to you, okay? You're going to come to my valley, and you're going to come to hear us and see what our conditions are. That's the agreement. If you want food, you're going to have to do that. If you don't want food, that's fine. Then you can accept food from a container from a third world country. But I don't appreciate that comment, okay? Everybody on this call is not engineers. I mean, there were some great comments that were written down and to the technical issue. I'm bringing it from a standpoint because you look pretty dang healthy. That means you've been eating food and you've been getting that food from me. And I would rather have the attitude you're willing to sit down and come and understand my industry before you tell me to go look on your data, okay?
Thanks, Manuel, for that comment. I really appreciate that. And we've actually enjoyed meeting with you and come up to staff myself and Shin have come up to Fresno to meet with you guys in the Farm Bureau. And we're happy to come up again and meet with you and go out to the fields. And we welcome that invitation. So thank you for that.
You got it. You got it. You have
really
it.
appreciate it, and we can coordinate offline and set up a date to whatever works for you. We can come out.
Fantastic. Thank you for that. Appreciate that. And we'll try to figure out how this idle entire issue fixes and temperature. So thank you.
You bet.
And Manuel, we totally recognize this proposal overall, and all the data supporting it is huge, very detailed, very technical. So we're happy to sit down and go through any portions of it sort of in layman's terms as well. That would help me as well. So thank you for asking that.
Thank you.
Yeah, and one other thing I just wanted to flag here, one benefit of the fact that we've pushed the proposed implementation dates. I don't know if I'm using the right terms, draft potential proposed implementation dates for
That's
Tier
correct.
5 final out to 2036, is that there's 10 years between now and then. So oftentimes when we're working on regulatory proposals, we're like, we need to get these emission reductions as fast as possible. And so we're coming right up against sort of the minimum legally allowed lead time. And then manufacturers are worried about having time to figure everything out and test it adequately. Because we have this 10 years, there's going to be adequate time to work through the very valid issues like the ones you're bringing up. We've done demonstrations on an engine, right? And there is work that needs to be done to make sure to incorporate that technology into all the different types of equipment that people use in the real world. So, okay, but thanks, Manny.
Well, thank you.
Perfect. Thank you, Manuel, for your questions and your comments. So we do have another raised hand from Christina Kubrin. So I will allow Christina to unmute. Please state your affiliation and your name. Oh, okay.
People are doing these accidental raise hand, which is fine. It's a sensitive button apparently, but that's fine. And don't be shy. If you've got questions, that's why we're here.
Hi.
All right,
Thank you
cool.
so much. I just put the lower hand down too soon. Christina Kubran, 352 Innovation, and I specialize in engines and specifically hydrogen combustion engines. And I just wanted to address Manny's comment that H2Is absolutely could be built to sit there and idle all day long at a low enough combustion temperature to stay out of the NOx formation zone. And because they run so much more thermally efficient than even diesels, they can run up 60–70% thermal efficiency. They could sit there and idle all day long and not be a worry and not make any emissions and sit out there and help us all eat some good food. So, Manny, we got you. H2Is is coming. Thank you. Christina Kubrin, 352 Innovation.
Perfect. Thank you, Christina, for your comments. Okay, so those were the raised hands that we had. I'll be switching back over to any written questions that we have. So to start us off, we do have a question from Jung Ho Kim from HD Construction Equipment. According to the PowerPoint, to determine NOx sensor accuracy, Southwest Research Institute aged at least 800 hours, but FUL is 8,000 hours. 800 hours aging NOx sensors are not enough to represent FUL. Are 800 hours aged NOx sensors using DAC or DAREP? Hanwi will be taking this question.
Yeah, thank you so much for the comment and question. So the 800 hours aging are based on the DAC aging, so which means you're absolutely right. Like that 800 hours may not be equivalent to the 8,000 hours of aging in terms of the NOx sensors. When we're having this contract with Southwest, and the Southwest run the sensors with 0 hours NOx sensors and 800 hours NOx sensors, and according to other data there, they kind of developed the correction algorithm. And one of the major function of the algorithm is to kind of correct this long-term zero bias, which could be caused by sensor aging. And we're kind of, this algorithm is doing a good job bringing the zero back to its true zero. So correction algorithm definitely help, but in terms of at the end of the useful life, really just keep in mind that really this screening program as a whole is really for flagging potential. And if you want more information, you can check our draft final report, which we will later post it after receive from Southwest. And from there, we definitely wish more feedback from stakeholders. If you have more data, and especially after 800 hours aging, what happens? And please share with us. We really welcome any feedback and data to support making this, sensor accuracy margin perfect. Thank you so much.
Perfect. Thank you, Hanwei. And thank you, Jung Ho, for your question. So moving on to our next question from Rakesh Malhotra from AGCO. How does one select engine families for manufacturer run in-use PEMS testing for small sales volume when the ECU or sensor data screening is optional? I believe Rakesh is referencing page 11 of the presentation, and Hanwei will take this question.
Yeah, let me go back to presentation so that everybody can see it. Oh, I'm sorry. Page 11. Okay, I'm going to share. Yeah, so for small California sales volume, it is optional for them to submit the ECU sensor data screening. And you can see from the power category here, it has two power category between 56 to 560. And especially for between 130 and 560, some of the sales volume may be less than 10 units. For between 56 to 130, those are above 10 units. We understand your concern that if you don't submit ECU or sensor data screening data, you may not have a reference for that, but please remember that we're not determining the manufacturer use PEMS testing solely based on the sensor data. So the sensor data is really trying to inform EO's decision or more on selecting the potential manufacturer run PEMS testing for those engine families. And I believe EO definitely have other criteria to consider when they're selecting engine family for testing, and especially for between 156, where some of those may less than 10 units, which doesn't satisfy the minimum testing article numbers for manufacturer run PEMS testing. So definitely those are covered, and those are just going to be based on EO's assessment, and ECU sensor data screening is not the only tool they have. Thank you.
Perfect. Thank you, Hanwei, and thank you, Rakesh, for your question. We do have another written question from Andy Suhi. How much actual PEMS testing was performed, and in what types of equipment during the developmental of these in-use testing requirements for Tier 5? I believe Jenna is going to take this question.
Yeah, thanks for this question. So as part of, I think I addressed this in the earlier section, so we did do in-use compliance threshold testing. That was an amendment to our Southwest Research contract before we set these potential requirements, and came up with duty cycles and did dynamometer testing. In terms of PEMS testing on a Tier 5 engine, I also mentioned that we don't have, that engine is a standalone engine in a test cell. It hasn't been attached to a piece of equipment. However, I can say that here at CARB, we do in-use off-road testing, and have been doing that. And we've tested multiple different types of equipment and applications and power ratings. I don't have the details off the top of my head in terms of what's been tested. I think some wheel loaders have been tested, some backhoes. I think that's my recollection. But we do our own in-house testing and using PEMS on Tier 4.
Perfect. Thank you, Jenna. And thank you, Andy, for your question. So I believe those are all the written questions that we have for now. Jenna, do you want to wait a little bit more to see if we get more questions or move forward?
Let's see. Yeah, I think that I don't know if Christian wanted to unmute himself and say a little something.
This is Christian Bartolome, supporting Tier 5. I think part of the question was asking how we might select engines for the small engine families, despite not having a screening program. So Jenna had already mentioned at CARB, we do a little bit of testing on our own, but similar to the on-roads program for the in-use program, um, there's a selection process where we might look for high sales volume equipment, or we might have information from either like warranty claims or things that from our OBD department of engine families that have of particular interest that we might select for the actual in-use PEMS testing by the manufacturer. And this process is for both the higher sales volume engine family as well as small sales volume family. So because the large sales volume family has more pieces of equipment and it has that telematics program, the large sales volume engine families have another mechanism for us to kind of screen and look for candidates for the PEMS testing. I hope that addressed your question. Thank you.
Thanks, Christian. Let's see. So Martha, are there any other raised hands?
So those were all the questions that we had. We don't have any new ones. At least
Okay.
not yet.
Well, terrific. I really appreciate this great exchange that we're having. It's really helpful for staff. We're taking notes. And there's also going to be the recording, as I mentioned before. And thank you, Hanwei, for giving that presentation. Really appreciate that. And then, as you noted, and I noted before, we did make a few changes to a few slides, and so we will post those changes because I do acknowledge that they are not on our website. We just wanted to make sure and put all the changes together at once in one document. So that was the reasoning behind that. So I think what we'd like to do right now is have the OBD folks now give their presentation. I know it was on the agenda, it's for the after lunch period, but I don't think we should wait around and waste folks' time. So we're just going to be expedient and introduce the folks. I think that Sana is the first person up.
Yes, hello. Let me go ahead and share the presentation.
And I didn't say your last name, Sana Data.
Oh, Data Boy.
Yeah.
Yeah, I know it's a little tricky.
I'm not going to say the obvious joke. So
Okay, can everyone see the presentation?
yes.
Okay. Hello, my name is Sana Databoy. I'm part of the OBD program development section. My manager, Jason Wong, wanted to open up this presentation with a couple words. So Jason, go ahead if you're ready.
Yeah, hello, can you hear me?
Yes, we can.
Okay. Yeah, I was gonna see how Jenna wanted to present it, but since she introduced you, I was okay if you just started. But since you mentioned me, I'll just introduce myself. Good morning, everyone. My name is Jason Wong, and I'm the manager of the OBD program development section that is in charge of developing an OBD program for Tier 5 off-road engines. Today, two of my staff, Sana Databoy, who you've already met, and Paul Hendrick, will provide an overview of major changes to our proposal, of our OBD proposal since our last workshop in October 2024. So with that short intro, please take it away, Sana.
All right, let's get into it. The first three slides are just acronyms. They're just here for reference, acronyms that we will be using in the presentation. I won't go over them now, but you can refer to these slides as we go through the presentation. Today, we will be talking about updates to the OR-OBD proposal. The draft OR-OBD regulation provided on the Tier 5 workshop website includes the details of the proposal. This draft regulation contains some revisions from the proposals we presented at the workshops in October 2023 and October 2024. And in this presentation, we will be covering the major revisions. In the original proposal, the applicability included electronically controlled off-road diesel engines certified to Tier 5 standards. In the revised proposal, the applicability would include off-road engines that are certified to the Tier 5 final standard, are equipped with an ECU that controls fueling, and are equipped with an ECU that controls intake airflow, EGR flow, turbocharger boost level, DEF injection quantity, regeneration events, after treatment thermal management strategies, or catalyst operating conditions. This slide is just a quick refresher of OBMD versus OBD. So Tier 5 final engines that are equipped with SCR systems or a tailpipe NOx sensor will be required to meet the OBMD requirements, while all other engines will be required to meet OBD requirements. The revised proposal eliminates the Phase 1 and Phase 2 terminology while retaining the 2 stages of implementation. We included this table as a reminder of the requirements of each stage. So Stage 1 includes limited standardization requirements, no diagnostic requirements, demonstration testing only for NOx mass accuracy, and no post-certification requirements. Stage 2 includes all of the Stage 1 requirements plus additional standardization requirements, OBD and OBMD diagnostic requirements, diagnostic demonstration testing, and post-certification verification requirements. Staff is also proposing to revise the schedule to align with the final Tier 5 implementation schedule by removing the parent-child rating distinctions and moving all power categories to the same schedule. Moving on to standardization requirements. The October 2023 proposal allowed the use of both SAE J1939 and J1979-2 communication protocols, but J1979-2 was removed from the October 2024 proposal. However, due to industry demand, the current proposal is once again allowing the use of both protocols. And this is an accidental duplicate of slide 10, so please ignore it. Staff is also proposing changes to the data stream signals. Engine percent load at current speed, ambient air temperature, barometric pressure, and SCR outlet temperature signals will be moved from the certification critical list to the so equipped list. And throttle position for engines so equipped will be added to the certification critical list to be consistent with in-use testing data logging requirements. Okay, now my colleague Paul Hendrick will be taking over. So Paul, please go ahead when you're ready.
Okay, thank you, Sana. Can you hear me?
Yes, we can.
Okay, great. Yeah, so I'm continuing with the standardization requirements. And what you see on the screen relates to our off-road real data tracking. So this overall structure is the same as what we had previously. So this just shows the different bins that the tracked parameters would be stored in, so the NOx mass parameters, the engine activity parameters, and so on. But to be consistent with the updates that Hanwei went over in that proposal, we are eliminating bin C. You can see there at the bottom that NOx screening 3-bin MA box there. So we're getting rid of bin C to be consistent. And that, if we go to the next slide, that is shown in more detail, exactly what that means here. So this table shows the different arrays and the different parameters that are involved in OR reel tracking. And anywhere you see a bin C, it's being crossed out. So we're keeping bins A and B where they are. If you look at the right-hand column there, lifetime engine activity array, you'll notice we've removed all of the moving average window bins, A through C. So that simplifies the implementation in the ECU. It reduces memory usage, and we think it was a good compromise. And in the last row, you'll notice that bins A and B were added to the total fuel consumption parameter, and that's consistent with a previous suggestion from industry. Next slide, please. So another piece to the proposal is relating to how these 300-second windows of data get sorted into the different moving average window bins. So our original proposal used the average power approach, where power was calculated using the torque and speed signals from the engine ECU, and then depending on what you get for a given window, you dump the data into the appropriate bin. What we're suggesting to change here is to move towards using a parameter called normalized CO2 emission mass instead of average power. So that change is going to harmonize with the official method that US EPA uses. So that's a good thing. And so what that looks like for bins A and B is that bin A will be defined for windows that have a normalized CO2 value less than or equal to 8%, and bin B will be for normalized CO2 greater than 8%. So basically everything else. Next slide, please. So this equation shows what this term really is. So the normalized CO2 emission mass is basically just the total CO2 mass over that 300-second window divided by those three terms that you see there in the denominator. And that's the standard equation used in CFR. So the only little wrinkle here relates to this, ECO2 term. And so what we're using for that, so it's the CO2 emission rate from certification test data, specifically from the emission data engine over the NRTC. So that's how it's being defined for this usage. If the engine is a constant speed engine, then it would be the same value from the steady state cycle. A Pmax is just the highest rated power for that engine family, and T window is just our familiar 300-second interval. Next slide, please. So for that proposed method to work, of course, we need to estimate what the CO2 mass is over that 300-second period. And so we are not expecting these engines to come with CO2 sensors. So we need to have another way to estimate that value. So what we're proposing here is that we leverage the O2 signal that is coming from the NOx sensors and use that. If you look in that second equation, that's where that percent O2 fits in. The basic idea is that we're approximating all of the oxygen that's being consumed by the engine to be partitioned into CO2 and H2O. Which is largely correct. And so using that, basically just using simple stoichiometry, you can estimate the percent CO2 as shown there. The 1.8 value, the conspicuous little 1.8 value in the denominator, that comes from CFR. So number 2 diesel fuel, sort of standard number 2 diesel fuel, they use a ratio of 1 carbon atom for every 1.8 hydrogen atoms. So that's the background on that one. We are happy to entertain alternatives that a manufacturer would like to propose. And it would, an alternative would just need to be at least as accurate as this method, or within plus or minus 15% of an official test facility result. Next slide, please. Related to these OR real requirements is the NOx mass accuracy requirement. So in our original proposal, this was a to be determined parameter. So we would require that the OBD system engine out and tailpipe NOx mass estimates satisfy a particular level of accuracy relative to lab results, and specifically over the certification test cycle. So this is really a certification requirement. It's not an in-use requirement. So just at the time of certification, we need to check to see that the ECUs are doing a good job of calculating the NOx mass. So what we're proposing now is to fill in the blanks, basically to say that the error relative to lab results must not exceed plus or minus 15% or plus or minus 0.08 grams per kilowatt hour. And this or means whichever is easier. So in practical terms, what this means is that the most important one here is really the plus or minus 0.08 grams per kilowatt hour. That would apply to the tailpipe accuracy test. And we expect that the 15% would be more relevant to the engine out NOx mass side of things. So next slide, please. So this proposal is based on test results that Hanwei introduced in his presentation from the Southwest NOx Sensor project that we funded. And so what I'm going to show you is the uncorrected NOx sensor data. So and as Hanwei mentioned, we are encouraged by the results of some relatively simple correction methodologies that Southwest has developed. But yeah, we'll look into that more in the future. So next slide, please. Okay, so this graph is showing NOx error. So this is the NOx emission rate error as determined by looking at the difference between what you would get using the NOx concentration and exhaust mass flow rate data from the ECU relative to the official lab results. So on the x-axis, you see numbers 1 through 10. We have 10 NOx sensors present. These are 10 NOx sensors sitting in the tailpipe position. And the number one sensor is the one that basically came with the engine. And there are 3 different make model combinations of NOx sensor present here. So sensors 1 through 4 is one make and model combination. Sensors 5 through 7 is another. And then sensors 8 through 10 are the third make model combination. And we have 4 different test runs being shown here, each with its own color. So there's 3 hot start NRTC cycles, and then 1 RMC cycle that are being shown. And you can see that these sensors do a really good job. For the most part, they easily would satisfy the proposed plus or minus 0.08 accuracy requirement. Some of the sensors in the first group are getting close to that, and what was observed is that these, and I should mention, these sensors were aged. So what was observed is that first make model group of sensors developed a positive offset. And although the offset correction method that Southwest developed did a good job at reducing that, I'm not showing that improvement here. These are just all uncorrected values. In addition to those 10 sensors that were in the tailpipe position, there was also, of course, one engine out NOx sensor. And looking at data from that relative to lab results from the raw gas measurements at the same position, we found that the NOx mass error never exceeded 6%. So our proposed 15% is looking pretty good. Next slide, please. Yeah, there's another piece to this. So in the original proposal, we're taking kind of the brute force approach to how to deal with negative NOx sensor concentration readings by just saying, okay, if you get negative values, set them to 0. We would like to revise that proposal, and because we do acknowledge there is value to some of the negative NOx sensor readings, as they would correspond to kind of the high frequency negative spike, positive spike, negative spike kind of noise that you can get, and so a negative spike could help balance out a positive spike, and so there's some value there. But we wanted to avoid a situation where prolonged negative values are present and negatively impacting results. So we have a 2-piece proposal to deal with negative values, and that is as follows. So we propose a cap so that the most negative value allowed would be -5 ppm, and that comes straight out of the SAE J3349 recommendation. And then the second piece is to cap the amount of time you have negative dwell. So the amount of time that that you get a string of negative concentration values. So we would cap that at 3 seconds in this proposal. So any negative values beyond 3 seconds would just be set to 0. Next slide, please. This is an illustration of the impact of that proposal. And it's basically what you're looking at is a graph of NOx concentration from a sensor over just a kind of a small slice of the NRTC cycle. So the red line there is the raw signal, and the blue line with the yellow dots is the effect of the negative backstop strategy. And I'll add that every yellow dot is basically 1 second. So if you look on the left side, there's not really much impact of the negative backstop strategy. Basically, the raw data is what it is, and but then you keep going a little bit further to the right, and then you start to see periods where the NOx sensor is dwelling in the negative domain quite a bit, and after 3 seconds, you see it gets pushed to 0. And there's also, if you look, a few places where the negative spikes are pretty negative, and so they get cut back to -5. So just graphically, that's what's going on. Next slide, please. Okay, so this graph is showing the impact of this approach on the NOx error. And so it's comparing 3 different scenarios. And we're only looking at one NRTC, one hot NRTC for this example. But we have the scenario where you have no negatives allowed, which is the original proposal. And then in red in the middle, you have where all negatives are allowed as is. And then finally, the negative backstop in green. So for those sensors that developed a positive offset, there's like no difference. All of these strategies, you'll get the same number. But if you look on the right, we have the sensors that had more substantial negative values, and the negative backstop approach does improve, or I'll say reduces the NOx error quite noticeably, about 50% or so. So that's good. That's a good thing to see. Next slide, please. Okay, so now we're shifting gears to another topic that has to do with monitor activity data. And this is largely unchanged from the original proposal. And this is just the tracking of how often each diagnostic runs. So you have a mini numerator counter that increments every time a monitor makes a decision, and you have a mini denominator that increments every time the general denominator increments, which is kind of a measure of the number of trips or operating cycles that have elapsed. And the only thing we want to do is provide some more detail on when to pause this tracking. So what we'd like to see is that if you have a particular type of fault code pop up that pauses the general denominator, then we'd want all tracking in all of the ECUs that are doing this tracking to pause. And that's because all of the mini denominators are looking to this general denominator to determine when they need to increment. So if the general denominator is paused, then all of the mini denominators will also be paused. And it would be unfortunate if the mini numerators continued to increment in some DEC ECUs and not others. So this makes sense to just pause everything across the board. But in the more general case where a fault code does not pause the general denominator, then we have our sort of default situation where you would only pause the tracking in that ECU that stored the fault code. Okay, yeah, it's kind of in the weeds, but we're just going over it. Okay, next slide, please. And then another piece of this relates to which ECUs would be required to support a mini denominator. So in the original proposal, we said that if the ECU is capable of storing a fault code, then it should also track and report a mini denominator. So in the revised proposal, we're adding a criterion to that. So in addition to storing a fault code, the DEC ECU would also need to track and report mini numerator data. So it wouldn't make sense to have a DEC ECU that tracks the mini denominator, but not a mini numerator, because ultimately you're taking a ratio of these values to determine a frequency of that the monitor is running at. And really what this is reflecting are those network architectures where you could have DEC ECUs that are capable of storing fault codes, but not necessarily tracking mini numerator data, because the manufacturer centralized that task in a different ECU. So yeah, so it's just a kind of a clarification here too. Next slide, please. Okay, so now we're really shifting gears, moving into diagnostic requirements, so leaving standardization stuff behind. And we're going to start talking about the OBM NOx emission threshold monitor. That's really the flagship monitor of the whole program. And so originally, what we proposed is that the NOx monitor would make decisions, pass-fail decisions, based on data that are stored in the OR-real moving average window bins. So originally it was a bin B and a bin C that were that this monitor would look in and collect 2,400 windows of data from those bins and use that data to judge if there are high NOx emissions or not. The problem with this approach is that there would be no monitoring taking place when the moving average window bins are paused due to the presence of a malfunction. So those bins, so the moving average window bins would pause for any fault code. And there's a problem because of the different purpose between these moving average window bins and OBM. So the purpose of these moving average window bins is to track the performance of the engine when it is free of malfunctions, and that's consistent with official in-use testing. But the purpose of OBM is to identify high NOx emissions that are caused by any malfunction. So I have a table. If we go to the next slide. Oh, or maybe it's the slide after that. But I'll get to the table in a second. So the basic proposal, because of that problem, is to use data, to have the NOx monitor use data that are independent of these OR-real bins. And so in essence, what that's going to mean is you will have different pause conditions. So the real bins will pause under one set of circumstances, and then the NOx monitor will have its own independent conditions. So the next slide will give an example of that. So in this table, we have a comparison of how the real bins will behave relative to the NOx monitor under a few conditions here. So as I mentioned before, if you have a fault present and the mill is on, and just the general mill, then you would have paused reel bins, and but we would want the NOx monitor to remain active, and that's for the vast majority of fault codes, which include if the engine out NOx sensor has a fault code or the SCR outlet temperature has a fault code. It doesn't matter. We would want the NOx monitor to continue to be checking for high emissions. But now more specifically, if the mill is on for a tailpipe NOx sensor malfunction, then everything's paused. And of course, that's because the NOx monitor is totally dependent on that tailpipe NOx sensor to make its decisions. So there is that alignment, but one notable difference is that in the case of the NOx monitor, what we would have is that you would reset all of the windows that were collected from since the last monitoring decision, which can be a lot, right? We're talking about as much as 2,400 windows of data, as opposed to just resetting the current 300-second window, as would be the case for the reel bins. And then third example here is when the engine out NOx sensor is reporting valid data, is not reporting valid data because the controller has identified some unstable condition. So the reel bins would pause, but the NOx monitor can remain active. And then the fourth condition is a frozen DEF tank. The tube and maw conditions do not prohibit collecting data under a frozen DEF tank condition. There's no fault present. It's just the DEF hasn't thawed yet. Of course, they do have an ambient temperature criterion of, I believe it's 5 degrees Celsius ambient temp or greater. So that should kind of take care of most of that problem, but on the surface, the frozen DEF tank is not a pause condition. However, for the NOx monitor, we would like to see that paused because it's a noise factor in determining when, whether there's an actual malfunction that's producing high NOx. So this is where we kind of flip, if you will, the active and paused states. Next slide, please. Okay, and then sort of the last, I think this is the last piece of the NOx monitor changes, but we don't see any need to have the NOx monitor, perfectly mimic the official end-use testing methodology. So we'd like to offer a lower memory approach to the manufacturers to form these 300-second windows. And so the idea is to allow an option of instead of having those 300-second windows comprised of 1-second intervals, to have 30 intervals comprised of 10 seconds each. So thanks for the industry suggestion on this, and it makes sense. So next slide, please. Okay. So what I was talking about previously had to do with requirements for engines that have SCR or a NOx sensor. So those were the OBM OBM-D requirements. Now we're shifting gears to talk about engines that do not have a NOx sensor, do not have SCR. So these engines are just simply called OBD engines, and they have different diagnostic requirements. So the first change that we'd like to propose is simply to add another section to our regulation that covers other emission control components that we don't explicitly have defined in the previous part of that regulation. So this is intended to cover emission controls that typically non-diesel engines might use, such as a hydrogen-fueled internal combustion engine. So just for completeness, we're trying to kind of cover these other bases. So we're listing out a catalyst that might not be a DOC, maybe a three-way catalyst, an air-fuel ratio sensor, and an oxygen sensor. And if down the road manufacturers adopt some other important types of emission control components, then naturally we'd add them to that list. Next slide, please. Okay. And now, as far as emission thresholds for these engines that don't, again, no NOx sensor, no SCR. The original proposal is as shown on this slide. We originally envisioned these thresholds to apply to engines that are in the power categories that have the really high emission standards, like 2.5 grams, 3 grams, 4 grams, 5 grams NOx. So these large values. So these kind of traditional multipliers were fine for that. But just to make sure we cover our bases, considering that other types of non-diesel technology could pop up, which could potentially meet those tighter standards in the other power categories without using SCR and a NOx sensor, we would like to kind of expand that table and produce some and propose some more appropriate, technically feasible OBD thresholds, and those are shown on the next slide. So what you'll see a bunch of these gram per kilowatt hour thresholds being added, and that is to create a large enough difference between the emission standard, which can be really, really tight, like the 0.04 gram per kilowatt hour standard for the 56 to 560 power category, to create enough of a margin between those tight emission standards and the OBD threshold that all proven diagnostic strategies would be appropriate. So we're not it's not technology forcing here. We want to choose OBD thresholds that reflect diagnostic strategies that have already been proven out for years in the field. So and I think that's my last slide, and I think it's back to Sana.
Yep, thank you, Paul. Okay, now we're going to move on to the changes in demonstration testing. Staff is proposing changes to the requirements related to tailpipe NOx mass accuracy testing, specifically the test engine selection criteria. The original proposal required that manufacturers conduct this testing on 1 to 3 engines per year, depending on the number of engine families the manufacturer certifies for that model year. The revised proposal would require manufacturers to test each engine with a tailpipe NOx sensor that the manufacturer submits an OR-OBD system application for. For OR-OBD certification documentation groups, that would be the representative engine. This will help determine if there are any issues with the engine's ability to accurately calculate NOx mass on a good portion of the engines, so that we can ensure that they are producing accurate OR real data in use. There are also changes to the test engine system aging requirement. The original proposal required that for stage 2 OBMD engines, the manufacturer would use a low-hour engine stabilized, the manufacturer would use a low-hour engine stabilized using the procedure they employ for emission certification, paired with a full useful life tailpipe NOx sensor, while all other engines would use a certification emission durability test engine system that is aged in accordance with a tailpipe certification aging requirement. We overlooked that stage 1 engines with tailpipe NOx sensors should also be using the same aged engine as the stage 2 OBMD engines, since the stage 1 engines would only be required to conduct the NOx mass accuracy testing under the demonstration requirements. Therefore, we are revising the proposal to allow stage 1 engines with tailpipe NOx sensors to use low-hour engines with a full useful life NOx sensor for demonstration testing. The original proposal did not include a definition for a full useful life age NOx sensor, so in the revised proposal, it is defined as a NOx sensor that has been aged together with an engine in accordance with the tailpipe certification aging requirements. For certification documentation, the original proposal required the representative engine to cover all emission control devices and monitors and diagnostics for all engines in the certification documentation group, and that the representative engine is certified to the most stringent emission standard in the group. In the revised proposal, the representative engine is required to be chosen from the engine family with the highest projected California sales number in the group, and from the engine rating with the highest projected California sales number in that engine family. Another change related to certification documentation requirements is the Diagnostic Link Connector, or DLC information. The original proposal required that manufacturers provide information about the DLC in their OR/OBD applications, specifically about the DLC description and locations on every equipment covered by the application. However, engine manufacturers have indicated to us that they are unable to provide this information at the time they submit the applications, since the equipment manufacturers will be the ones that install the DLCs. Therefore, staff is proposing to change the timing of submitting this DLC information to post-OR/OBD certification, specifically no later than 12 months after the start of engine production. Some changes were made to the model years in which deficiency fines apply. The original proposal split the implementation of fines by power category and parent-child ratings. With the removal of the parent-child rating distinctions in the revised proposal, staff is proposing that fines apply to all power categories for model year 2039 and up. And so that would be for stage 2 engines only. The number of deficiencies after which fines apply have also been changed. Originally, deficiency fines would apply to the third and subsequently identified deficiencies, but in the revised proposal, fines would apply to the fifth and subsequent deficiencies for model years 2039 through 2042, and to the third and subsequent deficiencies for model year 2043 and onward. Here's the contact information for the manager of the OBD program development section, Jason Wong, and the OBD branch chief, Mike Regenfuss. Thank you for your time today, and we will now be moving on to questions.
Perfect. Thank you, Sana and Paul, for the presentation. So I'll be starting off with the written questions we received through the Q&A box. If you do have a verbal question, just please raise your hand. If you're calling in, please dial in *9 to raise your hand. So to start us off with the first question by Aaron Shorey, NOx accuracy test. I believe there's 2 questions in here. So the first question is, will there be multiple preconditioning cycles allowed for learning any NOx offsets or gains in the sensor and correct for it before running the main accuracy test? The second question is, Did the test shown on slide 20 include cases where there are significant ammonia release? And has CARB studied how ammonia release impacted the NOx accuracy? So Paul will be taking this question.
Yeah, good questions, Arun. So for the first one, about preconditioning cycles, it's a good question because what is going to happen is you're pairing a full useful life aged NOx sensor with a low hour engine. Well, that's the sort of minimum requirement that we'd be proposing. So yes, I think it makes sense to have some preconditioning cycles to help achieve any stabilization and learning that needs to take place. We can take it back to see if maybe the regulation could benefit from some more detail in that particular area if it's not so clear at this point. So thank you. And then the second question, okay, talking about the data on slide 20 and ammonia slip. So that data did not include much ammonia slip at all, if I recall correctly. I'll point out that this accuracy requirement is strictly for testing at the time of certification. So yeah, I'd imagine that at the time of certification, control is pretty well achieved with the SCR system and so on. So we're not, this requirement would not apply to, some engine in the field that's accumulated, 5,000 hours of use and so on. So it's really just a requirement at the time of certification. So I think that should simplify and really reduce the ammonia slip concern. But thank you.
Perfect. Thank you, Paul, and thank you for the question. Our next question is from Rob Ways. Will PVE standardization testing J1939-84 or J1699-5 be required? And Jason will take this question.
Yes, thank you, Martha. Yeah, in answer to that, those software, the 1939-84 and 1699-5 would not be appropriate for this because the software has been developed for our it has been developed for this particular requirement, which is different from on-road. So for the initial years, a manufacturer would have to conduct this testing with their own device to check for, in this case, it would be Section I-1, the verification of standardized requirements. And you would have to come and request approval before testing of your device that you plan on testing on. And once it's approved, you could begin testing. So we need to do this before we have, we need to finalize this requirement so that industry can help develop that software to do the testing as some standardized software to do the testing similar to what we have for on-road.
Perfect. Thank you, Jason. And thank you, Rob, for your question. So moving on to our next written question from Dave Peich. This is extensive, so please bear with me as I read this aloud. What are CARB cost estimates for off-road OBD development by either engine family size? Anecdotally, in my experience for 2010 heavy-duty OBD, it cost over $20 million for a heavy-duty engine manufacturer to develop heavy-duty OBD for the parent engine in a single engine family that had over 50,000 plus engine sales in that engine family that went into only a few heavy-duty truck configurations. For off-road NCI or non-road NCI engines, these engines may be incorporated in tens of different pieces of equipment, with some equipment sales in California by equipment model and fewer than 10 or 20 annual sales in California. Off-road OBD requires compliance in all engines and all equipment. Even if the off-road OBD cost to ensure compliance across all equipment models is only a portion of that per family cost, the overall development cost becomes extremely problematic. And Jason will take this question.
Yes, thank you, Martha. Yeah, the short answer to Dave's question is that yes, of course we've done cost estimates. We've had a contractor that surveyed manufacturers on their estimated costs, and we've done internal analysis for the costs. And yet, Dave has mentioned that his experience from on-road some costs, but the on-road requirement is significantly different from the off-road requirement. The requirements in general are less stringent. It's less there's less overall requirements. It's more simplified, more streamlined, and there are more choices for manufacturers to comply with the regulations. And there's extremely generous lead time involved here. So we have done the cost, but you can't really compare the cost for on-road with the off-road. So I hope that answers his questions.
Perfect. Thank you, Jason. And thank you, Dave, for that question. Moving on to our next written question by Arun Shori. Paul, thanks for answering my questions on NOx accuracy test. I have a follow-up. Based on our recent on-highway experience on ultra-low NOx products, we are starting to see some ammonia release and FTP cycles as well. The NOx accuracy requirement shown here is stricter than current on-highway requirements, I believe. So it'll be good if CARB can study the current ultra-low NOx products, ammonia release conditions, and assess if there is anything could be learned for Tier 5 OPM NOx accuracy. And Paul will take this question.
Very good suggestion, Arun. We'll definitely do that. We don't want the requirement that we propose to be anything other than reflecting, the state of technology. It's this accuracy requirement's not meant to be technology forcing to, so it's a good suggestion, and we will follow up. Thank you.
Yes, thank you, Paul and Arun, for that question. So those are all the written questions we have for now. We don't have any raised hands at the moment.
Well, we'll take a 1-minute pause in case anybody has some last-minute questions. We're way ahead of schedule, but we're on schedule with our agenda in terms of taking the lunch break at 12:30. And if we don't receive any questions, then we'll just end the workshop at 12:30. I think that these have been fantastic feedback as well as suggestions, and it just goes to show the importance of having workshops like this. They're really helpful for staff in crafting a potential proposal or potential drafts. So we'll just give it a couple minutes, and then it's not your last time to ask questions. Of course, as we've mentioned numerous times, just send us an email in our Tier 5 box or to the OBD people, OBD folks that are on the presentation. You know how to get in touch with us. We've worked closely with most of you already. So you can, if you think of something, please email us, and we'll get back to you. We've had plenty of questions already pre-workshop and during the workshop, so just keep the questions coming. Happy to answer them. All right. Well, I want to thank everybody who attended today's workshop today, as well as staff who have worked with us behind the scenes and in front of the scenes, for really doing a fantastic job, and for your support, as well as for stakeholders' time and attention today. So thanks so much, and we'll talk to you later. Thank you. Bye-bye.